Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it.
We are beginning a new topic, plane geometry. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to calculate the angles on a point and a straight line. You should be able to identify and use the properties of parallel lines. You should be able to identify and use the angle properties of triangles and quadrilateral. And you should be able to state and use the circle theorems. So in this topic on plane geometry, we are going to concentrate on angles. So let's begin by learning what angles are. Angles are formed when two lines meet. In JHS, we learned this definition of angles. So what this means is this. Let's say we have this line here, line AB. I'm going to bring my pointer so that I can show you. We have this line here, line AB. Now we have another line, line CD, crossing line AB. Now as soon as CD crosses AB, we've created about 4 angles here. So we have an angle here, we have another one here, we have another angle here, then another angle here. So this is what we mean by angles are formed when two lines meet. Immediately CD meets AB, angles will be formed. Now we are going to call their point of intersection, the place that they meet, we are going to call the O. So the point of intersection of line AB and line CD, we are going to call the O. So we are calling this angle that we have here, the angle formed between A and D. We are calling that angle, angle M. Let's call it angle M. Let's call the one that we have here, angle M. Let's call this angle X, and let's call here angle Y. Now I'm using these variables N, M, X, and Y to represent the value, the actual value of this angle. Now we are going to learn how to name an angle. An angle is named using the points that are forming the angle. So for example, for angle N, the points that are forming angle N are points A, O, and D. So A, O, and D are the points forming angle N. So the name of angle N is angle AOD or DOA. Again, the name of this angle here, which is angle N, is angle AOD or DOA. Because when naming the angle, you use the points that form the angle, and always the point on which the angle falls must be in the middle. So here the angle is falling on point O, so the name is AOD or DOA, and it's written as, so angle N here, we know that is AOD or DOA. For simplicity's sake, I'm going to use AOD in this explanation. So angle AOD is written as this. You write this less than symbol, then AOD. Or you write AOD, then you make this sign on top of O, since the angle is on O. All that is clear. So this angle here, which is angle N, is called angle AOD or DOA. And it's written as this sign here, this less than sign, which is read as angle. So angle AOD, or you write AOD, then you make this sign here on the point on which the angle is falling, which is point O. So AOD, then you make the sign on point O. All that is clear. Now let's move on to the next angle. We know that we call this angle here angle M. So to name this angle is going to be angle BOD or DOB. It's still O because the angle is falling on the point O. So the name of this angle here, the angle formed between D and B, is angle DOB or BOD. It can be either one. The main thing that you have to make sure that happens is that the point that the angle falls on must be in the middle. So this is angle BOD or angle DOB. And it's also written as angle BOD or BOD, then you bring the sign on top of it. Somebody can also choose to write angle DOB or DOB, then you bring the sign on top of the O. The same thing applies to what we have here as X. This is also angle COB or angle BOC. Now it's written as angle COB or COB, then with this accent on top of the O. Lastly, this angle is also angle AOC or angle COA. It's the same thing. All that you need to know is that this is how to write it. So you bring this sign here, angle AOC or AOC, with this sign on top of the O. We are going to use this a lot in the video that in the subsequent videos that you will be considering. So you should be conversant with it, so that when I mention an angle, let's say I mention angle AOC, you know that the particular angle I'm talking about. In this video, we are going to also consider the types of angles. We learned so much about this in GHS, so we are going to go over it. We have one angle called the acute angle, an angle whose measure is less than 90 degrees. Angles are measured in degrees. So whenever you have an angle and the value of the angle is less than 90, we say that that angle is an acute angle. So for example, 50 degrees is an acute angle, 20 degrees is an acute angle, 89 degrees is an acute angle. Any angle less than 90 degrees is called an acute angle. We have another one called the right angle, an angle whose measure is 90 degrees. So when you measure an angle and you get 90 degrees, that angle is called a right angle. Another one is called an obtuse angle, an angle whose measure is greater than 90 degrees but less than 180 degrees. So if you have an angle whose value is greater than 90 degrees but less than 180 degrees, for example 120 degrees, 120 degrees is greater than 90 degrees but less than 180 degrees, we say that you have an obtuse angle. Let's consider another type of angle called the reflex angle, an angle whose measure is greater than 180 degrees but less than 360 degrees. So an angle whose measure is greater than 180 degrees but less than 360 degrees is also a reflex angle. An example of that is 170 degrees. Example of that is 270 degrees. 270 degrees is greater than 180 degrees but less than 360 degrees. So we say that that is an example of a reflex angle. Then we have complementary angles, two angles that add up to 90 degrees. So when you have two angles and you add them up and you are getting 90 degrees, we say that they are complementary angles. All that is clear. If you have two angles, you add those two angles and you get 90 degrees, those two angles are said to be complementary angles. Then we have supplementary angles, two angles that add up to 180 degrees. So if you have any two angles, you add them up and you are getting 180 degrees, we say that they are supplementary angles. For example, if you add 60 degrees to 120 degrees, you are going to get 180 degrees. So we say that 60 degrees and 120 degrees are supplementary angles. We've learned about the types of angles. In this video also, we are going to learn about the properties of angles. Now pay attention to this very, very well. Properties of angles. And the first property we are considering is angles on a straight line. Let's say we have this straight line as we have here, line AMB as we have here. Now this is the straight line. We have FM, line FM joining line AB. Then we have line GM also joining line AB. Now you see, when that happens, you are going to create about 3 angles here. So we have this angle here which we are calling x, we have this angle here which we are calling y, and we have this angle here which we are calling x. Now this property states that angles on a straight line add up to 180 degrees. So whenever you have angles on a straight line, if you add all those angles up, you are going to get 180 degrees. So what this means is that if we add x to y to z, then we must get 180 degrees. This property of angles is very, very important. We are going to use it in the subsequent videos a lot, so make sure you get it. If you have a straight line and you add all the angles on the straight line, you must get 180 degrees. Let's look at the next property. Angles around a point sum up to 360 degrees. We learned in the previous slide that angles on a straight line add up to 180 degrees. This time it's not angles on a straight line, but it's angles around a point. So we have line AB and line FG. They meet at a point called O. Now O becomes a particular point. When you add all the angles around the point O, we are saying that you should get 360 degrees. So whenever you have a point, if you add all the angles around the point, if you add all of them, you must get 360 degrees. So what this means is that if you add A to B, you add that to C, and you add that to D, you must get 360 degrees. This is also very, very important. We are going to use it a lot as the video goes on. Let's look at the next property that we are considering. Vertically opposite angles. Vertically opposite angles. Let's say we have this line here, line PS and line RQ. Now they meet at a point O. We have about 4 angles formed here. We can see from here that N is directly opposite to M. P is directly opposite to R. These are what we refer to as vertically opposite angles. So N is vertically opposite to M, P is vertically opposite to R, and the property is telling us that vertically opposite angles are equal. It makes sense, right? So if P is directly opposite to R, then it makes sense that P is equal to R. N is also directly opposite to M, so we say that N is also equal to M. So we are saying that N is equal to M and P is equal to R. Remember, these are also angles around a point, so if you add all of them, you should get 360 degrees. N and P are angles on a straight line, so if you add N and P, you should get 180 degrees. R and M are angles on a straight line, so when you add them, you should get 180 degrees. But on this slide, what you are considering are vertically opposite angles. We know that P is vertically opposite to R, so P is equal to R. N is vertically opposite to M, so N is equal to M. This property is also very, very important, and we are going to use it a lot. Let's look at the last property that we'll be considering in this video. Angles formed between 2 perpendicular lines is 90 degrees. Now when you have 2 perpendicular lines, on the video on mensuration and straight lines, we said that 2 lines are said to be perpendicular if they meet at 90 degrees. So in this case, line AB and line BC meet at 90 degrees. So we say that line AB and line BC are perpendicular to each other. We say that if you have 2 perpendicular lines and they are meeting, the angles formed between them is 90 degrees. So here the angle ABC, which is this angle we are talking about here, is 90 degrees. Now whenever you see this sign, it means that the angle there is 90 degrees. So whenever you see this sign, now this is what I mean. If you have, let's say you have this line here and you have another line, and you see this sign in between them, it means that the angle formed around that particular area is 90 degrees. So here the angle formed here is 90 degrees. So we've learned about 4 properties here. We've learned about the angles on a straight line. We know that they are equal to 180 degrees. We've learned about the angles around a point. We know that they are equal to 360 degrees. We also learned that vertically opposite angles are equal, and we've learned that the angles formed between two perpendicular lines is 90 degrees. Now, in the next video, we are going to use these properties that we've learned in this video to solve questions. See you in the next video. Bye bye. We are on the topic plane geometry, and this is the second video on plane geometry. In the previous video, we considered some properties of angles. In this video, we are going to use the properties of angles that we considered in the previous video to solve some questions. So let's begin by picking the first question. The question says that we should find the value of the letter in the following diagrams, and this is the first diagram. So we can clearly see from here that line AB and line BC are perpendicular lines, since the angle ABC is 90 degrees. We said in the previous video that whenever you see this sign, it means that the angle formed there is 90 degrees. So here, that is the property we are going to use. So whenever the question is given to you, you look at the diagram very carefully, then you look at the property that will help you to solve the question that has been given to you. Okay, so here, the angle formed between line AB and line BC, which is angle ABC, is 90 degrees. So we see that line AB and line BC are perpendicular lines, and we know that the angle formed between two perpendicular lines is 90 degrees. So if the angle ABC is 90 degrees, and that same angle ABC is 78 degrees plus x, we know that here angle ABC has been divided into two, and a part of it is 78 degrees, the other part is x. We are supposed to find it. But we know that when you add all of them together, you should get 90 degrees. So we can say that 78 degrees plus x is also the same as 90 degrees. From here, it becomes a linear equation, and we know that x will give us 90 degrees minus 78 degrees, which is 12 degrees. So you look at the diagram very carefully, then you quote the property that will help you to solve the question. Let's look at the next one. We are supposed to find the value of the letter here. In this case, the letter that we have is C. So which property will help us to solve this question? I can think of two. The first one is angles on a straight line. The straight line being line MP. We know that angles on a straight line add up to 180 degrees, and 80 degrees and C are on the straight line MP. If you add all of them, you should get 180 degrees. So 80 degrees plus C will give us 180 degrees. Then we make C the subject from there. I can also see that C and 100 degrees are vertically opposite angles. We learned in the previous slide, in the previous video, that vertically opposite angles are also equal. So straight away I can see that C is equal to 100 degrees. That is easier. So between angles on a straight line and vertically opposite angles, I think vertically opposite angles will help us to solve the question faster than angles on a straight line. So I'm going to pick vertically opposite angles. So I can see that vertically opposite angles are equal, and angle AOP, which is C, is equal to angle MON, which is 100. So C is equal to 100 degrees. Simple. As I said, somebody can also say that angles on a straight line are equal. So you pick 80 degrees and C and then add them and equate to 180 degrees. That will also be correct. But this is faster. So I always pick the one that will help me to solve the question faster. Let's look at the next question. So we have this clumsy diagram here, and we are supposed to find the value of the letters here. So the letters being G, F, I, N, and J. So let's look at this also very carefully. Now we can see that we have some vertically opposite angles here. So we choose that, since that will always give our answer easier or faster. So I'm going to bring it here so that we can write our solution at this place. So here we can see that J and 46 degrees are vertically opposite, so they are equal. I and 44 degrees are also vertically opposite, so they are also equal. F and 50 degrees are also vertically opposite, so they are also equal. G and N are vertically opposite, so if you're able to find one of them, you have the other. So let's begin by picking the one that we already have their value. So we know that vertically opposite angles are equal, and angle BOM is J, is equal to angle NOG, which is 46 degrees. So J is equal to 46 degrees. Very, very simple. We also know that angle GOZ, which is I, is equal to angle QOB, which is 44 degrees. So I is also 44 degrees. Then we have also seen that angle YON, so YON, which is F, is equal to angle MOV, which is 50 degrees. So F is also 50 degrees. So we have been able to find 3 of the letters here. We have found J, we found I, and we found F. We know that G is also vertical opposite to N, but we don't know one, so we have to find the other. Then we can say that the answer is the same for the other one. So we'll be able to find the value of G is the same as the answer for N, since G and N are vertical opposite and vertical opposite are equal. So let's look at a way to find G or N. I'm seeing angles on a straight line. If I pick the straight line QZ, you know if you add all these angles, G to F to 46 degrees to N, and equate it to 180 degrees, you should be able to find the other. Since we now know the value of F and I, that will be easy. Somebody can also pick 44 degrees, J, 50 degrees and N, and equate that one also to 180 degrees, since they are also on the straight line Q and N. In fact, somebody can also pick J, 44 degrees, F and G, since they are also on the straight line N, M. So most of the time there will always be more than one way of solving this. There will always be more than one way of solving this. So you have to look at it and pick the way that is one easier for you, one that you can understand and handle what the equation that you are going to have. So here I'm going to pick angles on a straight line, and I'm picking the straight line, I think QZ. So angle QOB will be the same as 44 degrees. Angle BOM will be the same as J. Angle MOV will be the same as 50 degrees, and angle VOZ will be the same as N. So from here I can say that 44 degrees plus 46 degrees, since J is already 46 degrees, plus 50 degrees plus N will give us 180 degrees. Then I will say that 140 degrees, sorry, this is supposed to be degrees. I'm going to deepen here so that you can get it. So degrees, sorry, I was not able to write that well. So 140 degrees plus N is equal to 180 degrees. You make N the subject and you are going to have 40 degrees. So we found N, but we also know that G and N are vertical opposite. You know that vertical opposite angles are equal, so G will be equal to N. So if N is 40 degrees, then G is also 40 degrees. So as I said, you look at the diagram very carefully, you state the properties that you know, then you pick the one that will help you to solve the question. Usually one property will help you to solve it faster than the other, so you pick the one that will help you to solve it faster. Let's look at this question here. We have line AV and line KB. They meet at a place called M. Now where they meet, we can also see that this angle that we have here and the whole angle that we have here are vertical opposite. So if you are supposed to find X, we can equate what we have here to what we have here, then we'll be able to find X. I'm going to shift the diagram here so that we can solve it. So we say that vertical opposite angles are equal, and angle AMB, so AMB, which is this angle here, 2x, is equal to angle KMV. Angle KMV is made up of two angles, 55 degrees and 40 degrees. So the whole angle here is equal to the whole angle here. So we can see that 2x is equal to 55 degrees plus 40 degrees, since vertical opposite angles are equal. So what we do is that 55 degrees plus 40 degrees will give us 95 degrees. So 2x is equal to 95 degrees. When you make x the subject, you are going to have 47.5 degrees. So this is one way of doing it. Somebody can also pick another way. Now you can see that the angle that we have here, the empty space that we have here, 55 degrees plus 40 degrees plus this angle that we have here will give us 180 degrees, since angles on a straight line is 180 degrees. Now when the person finds that, you can say that 2x and that angle that you are going to have here is also angles on a straight line, on the straight line AV. So you can also equate that one to 180 degrees, then find x from there. But you see, that is a long process. Angles on the vertical opposite angles will give us a very fast way of solving the question. So you always pick the one that will solve the question easily and quickly. Thank you for watching this video. Pick more examples on questions of this nature. Try your hands on them. If you are not able to solve it, or if you face any problem, interact with me on my social media handles and I will help you to solve it. See you in the next video, where we will consider the angle properties of parallel lines. Bye bye. We are still on the topic plane geometry. In the previous video, we looked at some examples based on the properties of angles that we saw in the first video, and we solved those examples. I hope you picked a couple more and tried your hands on them. In this video, we are going to look at the angle properties of parallel lines. So let's begin by looking at what parallel lines are. Parallel lines are lines that do not meet. So for example, in the diagram that we have here, we have the line AB and the line XY. Now to indicate that they are parallel lines, you draw this arrow in them, showing the direction in which they are moving. Now you can see clearly that if this line continues and this line also continues, there is no way that they are going to meet. So we see that line AB and line XY are parallel lines. Now when you have a parallel line like this, and you have another line crossing the parallel lines, you are going to form different types of angles here. Now we are going to consider the properties of these angles in this video. So we say that line A, B and line XY are parallel lines, and the line crossing the parallel lines is called the transversal, or the transversal line. So line AB and line XY are parallel lines, and the line crossing them is called the transversal. So whenever you have two parallel lines or two or more parallel lines and you have a transversal, you are going to form some different types of angles, and we are going to consider the properties of these angles. The first type of angle you are going to form whenever you have this is what we call the alternate angles, or the alternating angles. Now where can we find them? You can see in this diagram that we can have an angle here which is C and an angle here which is F. Now look at the position of C and F very, very carefully. So we can have this angle here, which is angle C. Then we have this angle here, which is angle F. Look at their position very well. We can also have this angle here, which is angle D. Then this angle here, which is also angle E. So angles C and F and angle D and E are alternating angles, or alternate angles. So we see that the following angles are alternate angles. So C and F are alternate angles, and D and E are alternate angles. Once again, look at their position very well. So C is here, F is here, D is here, and E is here. So we say that C and F are alternate angles, D and E are alternate angles. And what is the property of alternate angles? Alternate angles are equal. So in this diagram, C is equal to F and D is equal to E. So C and F are alternate angles, D and E are alternate angles, and alternate angles are equal. So C is equal to F and D is equal to E. So we've learned the property of alternate angles. Another angle that will also be formed is what we call the corresponding angles. Now, what are their position on this diagram? We can see that there will be an angle formed here. We are going to call this angle here angle A. There's also another angle formed here. We are going to call this angle angle E. Now look at it very well. You will see that this is the parallel line here. Now the transversal is crossing it here. Look at the position of A and look at the position of E. We say that they are corresponding. So A and E are corresponding angles. In the same way, another angle will be formed here, which is C. Another angle will be formed here, which is also G. Look at their position also well. So C is here and G is here. We say that C and G are also corresponding. Another angle will also be formed here. So look at this one, B. Another one also formed here, F. We say that B and F are corresponding. So A and E are corresponding. The top is corresponding to the top. Then the down is also corresponding to the down. When you come here, C and G are also corresponding. Then D and H are also corresponding. So D is corresponding to H. Now, what is the property of corresponding angles? I'm going to clean this so that you see it well. So we see that the following angles are corresponding. So A and E are corresponding, C and G are corresponding, B and F are corresponding, then D and H are also corresponding. What are the properties? Corresponding angles are equal. So when you come here, A is equal to E, C is equal to G, B is equal to F, and D is equal to H because they are corresponding angles. Once again, look at their positions very, very well. So A corresponds to E, C corresponds to G, B corresponds to F, and D corresponds to H. In the previous slide, we considered alternating angles. Now we can see that B and G are alternating angles, D and E are alternating angles. We've moved on from there. We are now considering corresponding angles. So here, A and E are corresponding, C and G are corresponding, B and F are corresponding, D and H are also corresponding. And what do we know about corresponding angles? Corresponding angles are equal. Another type of angle that we form is what we call the co-interior angles. Co-interior angles. Now, what are their position? We can see that an angle will be formed here, and we are going to call this angle here angle C. We are going to call this angle here angle C. So this is angle C, and this is angle C. Now, another angle will also be formed here, so we are going to call this angle angle D. Then we call this one angle F. These are what we refer to as co-interior angles. So we say that the following angles are co-interior. C and E are co-interior angles. Then D and F are also co-interior angles. What are the properties of co-interior angles? Co-interior angles add up to 180 degrees. So once again, alternate angles are equal, corresponding angles are equal, co-interior angles add up to 180 degrees. So what this means is that C plus E will give us 180 degrees, D plus F will give us 180 degrees because they are co-interior angles. Once again, remember that you can only have alternate angles, corresponding angles, and co-interior angles if and only if you have parallel lines with a transversal crossing it. If there are no parallel lines, you can't use any of these properties that we've learned. We are going to use the properties that we've learned, these three properties, and add it to the previous properties that we learned in the previous video to solve this question that we have here. Find the value of the letters in the diagram below. So we have the letters I, H, and G. Now, we are supposed to use the properties that we've learned in this video and the previous video to solve this question. So, as I always do, I'm going to shift it to this side so that we can solve it. Just as we did for the previous video, whenever you are being given the question, consider the question carefully and recall the properties that you know, then use it to solve the question. You can start from any one of your choice. Now let's look at this very carefully. We just learned that corresponding angles are equal. From this angle, from this diagram, we can see that H is corresponding to 120 degrees. If you look at what we have on corresponding angles here, we can see clearly from here that D and H are corresponding. D and H are corresponding. You can see that D and H corresponding is the same as H and 128 degrees. So the down part corresponds to the down part, the top part corresponds to the top part. This is what I mean. So we have H here, which is below, corresponding to what we have here, which is also below. I will correspond to this part here, which is empty. That is not what we are interested in. We are interested in what we have here, which is H. So because H is corresponding to 120 degrees, we know that to 128 degrees, we know that corresponding angles are equal. So H will give us 128 degrees. That is simple, right? Now, let's look at the relationship between H and G. We said that looking at the position of H and G are alternate angles. Look at the position very well. H and G are alternate angles or alternating angles. So H and G are alternate angles. What do we know about alternate angles? Alternate angles are equal. So H is equal to G. We've already found G to be 128. We already found H to be 128 degrees. So G is also 128 degrees. Now let's look at another simple way of doing this. We know from the previous slide that vertically opposite angles are equal. Now look at something. G is vertically opposite to 128 degrees. So we can also use that and say that G is equal to 128 degrees. So consider the diagram very carefully. Then recall all the properties that you have and pick the one that will help you to solve the question. So here we found H, we found G, we are left with I. How do we find I? Now let's look at it very carefully. We can see from here that I and H are on a straight line. Sorry, we can see that I and H are on a straight line. Now we know from the previous video that angles on a straight line add up to 180 degrees. So if you add I to H, you must get add up to 180 degrees. So if you add I to H, you must get 180 degrees. So I plus H will give us 180 degrees. Sorry. So I plus H is equal to 180 degrees. We have already found H to be 128 degrees. So we say that I plus 128 degrees will give us 180 degrees. Then if you simplify, you are going to have I to be equal to 180 degrees minus 128 degrees. Then I is equal to 52 degrees. So we found I, we found H, and we found G using the properties that we've learned in this video and the previous videos. Once again, you can only use alternate angles, corresponding angles, and co-interior angles if and only if you have parallel lines with a transversal crossing it. Now when you have that, you can use these properties and you add it to the previous properties that we've learned and you use them to solve the question. Thank you for watching this video on plane geometry. Pick some more examples and try your hands on it. In the next video, we are going to pick some more questions that involve parallel lines and transversals. Bye bye. We are still on the topic plane geometry. In the previous video, we considered the angle properties of parallel lines, and we took an example on questions that involve parallel lines. In this video, we are going to solve a couple of examples. So let's pick the first one. Find the value of the letters or the letters in the following diagrams. So we have the first diagram here. So we are going to find the value of x and y in this diagram. Now I'm going to bring it here as I usually do so that you'll be able to solve it. Now we can see from here that we have three parallel lines, AB, CD, and EF. Now we have two transversals, IH and HG. Now whenever you have this, you solve it one at a time. So in solving the top part, we consider it as if what you have here is not there. So we are going to solve only this part. We are going to consider A, B, and CD with IH being the transversal. Now if you are considering that, you can see from here that 120 degrees and X are co-interior angles. If you watch the previous video, you can see from here that 120 degrees and X are co-interior angles. What we know is that co-interior angles add up to 180 degrees. So X plus 120 degrees will give us 180 degrees and X will give us 60 degrees. So we solve for the X that was in this part. Now you come here. When you come to the down part, you consider it as if this part here does not exist. So we are solving CD and EF with GH as our transversal. Considering that one too, we can see that Y and 70 degrees are alternating angles. We know that alternating angles are equal, so Y is equal to 70 degrees. So whenever you are being given the diagram, all you need to do is to look at the diagram very carefully. Then you recall all the properties that you know and use the one that will help you to solve the question. From here, we know that X and 120 degrees are co-interior angles, so we can find X from there. Y and 70 degrees are alternating angles, so we can find Y from there. It is that simple. Let's look at the next question. So we have this question here, and this one we are supposed to find X. Now, how do we solve this question? Now you can see from here that we have J and K, we have M and N as the two parallel lines from here. Now we can see that the transversal doesn't continue straight onto the other parallel line. Whenever you have this, to help you solve this type of question, what you have to do is that you have to introduce a helping parallel line or a parallel line that will help you to solve this question. Now this is what I mean. You see, in the previous video, we had this parallel line, then we had a third parallel line in the middle. That is the same thing that you are going to do here. You are going to bring an auxiliary parallel line, an imaginary parallel line that will help you to solve this question. It was not there in the question, but you have to introduce it so that you'll be able to solve. Now this is what I mean. You bring an imaginary parallel line. Now as soon as you bring this imaginary parallel line, you see that it looks similar to what we solved in the previous video. Now you can proceed and solve. Now if you bring this parallel line here, remember before the parallel line came, this whole angle was X. Now if you bring this parallel line, you have divided X into two parts. This part here and this part. We are going to call the first part here A, then we call the second part here B. So it means that if you're able to find A and B and we add them, we are going to get X, because the whole place used to be X. We brought this imaginary parallel line to divide it into two. We have a part called A and a part called B. So if you're able to find A and B and we add it, we should get X. Now with this, we can proceed and solve. So this is the parallel line, the imaginary parallel line that is helping us to solve. So with this parallel line, we are now going to consider JK and this parallel line here, the one with the short dashes. And in considering that, you see that BA is our transversal. And from here, we can see, looking at the position of A and 50, 4 degrees, we can say that alternating angles are equal. So A is equal to 54 degrees because A and 54 degrees are alternating angles. So we found A. Let's look at B. So it means that we are done with this top part. So we are going to consider the down part here. In considering the down part here, we can see that B and 130 degrees are co-interior angles. What do we know about co-interior angles? We know that co-interior angles add up to 180 degrees. So B plus 130 degrees will give us 180 degrees. You simplify, you are going to get 180 degrees minus 130 degrees. So B will give us 50 degrees. So we've now found A, we found B. So we can say that S is equal to A, which is 54 degrees, plus B, which is 50 degrees. So S will give us 104 degrees. So whenever you have a question like this, what you have to do is that you introduce an imaginary parallel line, a helping parallel line, so that you can be able to solve the question. Let's consider another example. A typical example is this one. Now we are supposed to find X, we are supposed to find Y. How do we do it? Now, because you have this and the transversal is not continuing up to this line, what you have to do is that you introduce a helping parallel line. So we are going to introduce this helping parallel line here. Now, as soon as you introduce this helping parallel line, we can see from here that it's going to divide the X into two parts. Let's first consider the X before we move on to the Y. It's going to divide the X into two parts. So N here, we are going to call this first part here N, and we are going to call this one N. Remember that you can pick any variable, any letter, you can use it to solve. All that you need to do is to keep track of the letters that you are writing. So we can say that X is equal to N plus M because we've divided X into M and N. Now, how do you find M and N? Let's first begin with corresponding angles. We can see clearly from here that N is corresponding to 40 degrees. We know that corresponding angles are equal, so N is equal to 40 degrees from here because N and M are corresponding. Now we can also see from here that M and 150 degrees are co-interior angles. We know that co-interior angles sum up to 180 degrees, so M plus 150 degrees will give us 180 degrees and M will give us 30 degrees if you simplify. So we found N, we will also be able to find M. So X will give us 40 degrees plus 30 degrees and that will give us 70 degrees. So it means that we have now been able to find the whole X. So once again, you introduce the imaginary parallel line and use it to find the angle that you are supposed to find. So we find X. Let's move on to Y. Now we have been able to find X here. Y is here. Now you see that this is a point. X and Y are angles around a point. If you angles around this particular point here, if you add all of them together, in the first video we said that angles around a point will add up to 360 degrees. So we know that angles around a point sum up to 360 degrees. So X plus Y should give us 360 degrees. Since this is X, this is the point we are talking about. Now we have X here, we have Y here, so they must add up to 180 degrees. We have found S to be 70 degrees. So if we simplify, Y is going to give us 360 degrees minus 70 degrees, which is 290 degrees. So we have been able to find X, we have also been able to find Y. Thank you for watching this video. In the next video, we are going to consider some more questions on angle properties involving parallel lines. Bye bye. We are on the topic plane geometry. In the previous video, we picked some questions that involved parallel lines. In this video, we are going to pick some more questions which involve parallel lines. So we are being told that we have to find the value of the letter or the letters in the following diagrams. So you pick the first diagram here. So in this diagram, you are going to find the value of X and Y. So I'm going to shift it to this side so that we can solve. Now, we study the diagram very carefully. we have parallel lines and transversals, so we can use co-interior, alternating, or corresponding angles, or any of the three previous properties that we learned. Now, looking at this diagram very well, we know that vertically opposite angles are equal. So if vertically opposite angles are equal and this side, this angle here is 120 degrees, then I can also say that this angle here is also 120 degrees, since this side here, or this angle here and this angle here, are vertically opposite angles. Now if I have this to be 120 degrees, then from the properties of parallel lines, angle properties of parallel lines, I know that y and 120 degrees are co-interior angles. So I can say that co-interior angles sum up to 180 degrees. So y plus 120 degrees will give me 180 degrees, and y will give me 60 degrees. So you see that I wanted to find y, but in order to find y, I wanted to use the property of co-interior angles. So looking at this and this, I saw that 120 degrees is vertically opposite to this. So if I bring it here, I can say that co-interior angles add up to 180 degrees. So y plus 120 degrees will give me 180 degrees. There are so many ways of doing this. Somebody can also do it this way. He will say that y and this side here are alternating angles. So here is y. Now when you have it to be y, you are going to have y plus 120 degrees equal to 180 degrees using angles on a straight line. So you can do it in so many ways, and you will still be able to find it. So always pick the one that is convenient to you. We've done with x, we are done with y, so let's move on to x. How do you find x here? Now to find x here, I want to use the property of angles on a straight line. Now, so here is y, here is x. So I'm going to assume that this place here, I'm going to write another letter here, or a variable here, which is y, so which is v. So I'm assuming that this place here is v. So if I'm able to find the value of v, I know y already, I'll be able to find x. Now how do I find v? To find v, I want to use co-interior. Now v and this side here will be co-interior. V and this side here will be co-interior. But how do I find this side here? So I'm saying that angles on a straight line add up to 180 degrees. So y plus x plus v will give me 180 degrees. This is what I want to use. I already know y. X is what I want to find. So it means that I have to find v. If I'm going to find v, then I'll be able to find x, since that will be the only variable left. Now to find v, I want to use the property of co-interior. So v and this side here are co-interior. So I'm going to assume that here is a certain variable called w. Now you can see from here that w and 140 degrees are vertically opposite. We know that vertically opposite angles are equal. So w will give me 140 degrees. So I've been able to find this side here to be 140 degrees. So v and w are co-interior. I can now use the co-interior that I wanted to use. So v and w are co-interior angles. We know that co-interior angles add up to 180 degrees. So v plus w will give us 180 degrees. I know w to be 140 degrees. So v will give me 40 degrees after I simplify the whole thing. Now I have y, I have v, so I can find x. So with y and v, I can find x, because I know that y plus x plus v will give me 180 degrees, since angles on a straight line add up to 180 degrees. Y is 60, v is 40. So I'm going to have 60 degrees plus x plus 40 degrees to give me 180 degrees. So x will give me 80 degrees after I simplify the whole thing. Let's consider another question here. So we have this diagram and we are supposed to find x. Now you can see from here that x is outside. X is the angle out here. Now to find such an angle, what you have to do is that it's always easier to find the inner angle. To find the angle that we have here, the inner angle, then you subtract that from 360 so that you get the outer angle, since we know that angles around a point will add up to 360 degrees. So this is what we are going to do. We are going to call this point here point O, as I have here. Then we bring another variable here which will cater for the inner angle here. We are going to call that P. Now, because we have a parallel line here, a parallel line here, the transversals do not continue to the other side of the parallel line. As we did in the other video, we are going to bring an alternate straight line, an alternate parallel line, which is this parallel line here that you have here, an imaginary parallel line. Now, we know that before we bring this imaginary parallel line, because we have written here as P, or because you have indicated this side as P, we already know that the outer angle is X. Right now we have the inner angle to be P. If you add X to P or P to X, you are going to get 360 degrees, since angles around a point. So angles around this point O, if you add all of them, you should get 360 degrees. So to help us to solve this, we bring this imaginary parallel line here. Now, this imaginary parallel line is going to help us to find the inner angle. Then we can now subtract it from 360 degrees. Then we get the outer angle. All that is clear. Now, as soon as you bring this imaginary parallel line, it's going to divide the P that you brought here into two parts. So it's going to divide it into, I'm saying that this is going to divide into X and H. So from this, I can say that if you want to find P, find Z. It's going to divide into Z and H, sorry. So if you want to find P, find Z and H and add it, and you'll be able to get P. I hope that is clear. So let's begin by finding Z. Looking at this carefully, looking at position of 52 degrees and Z, we can see that Z and 52 degrees are alternating angles. Look at their position very well. Z is here, 52 degrees is here, and they are alternating angles. We know that alternating angles or alternate angles are equal, so Z is equal to 52 degrees. Now, looking at the position of H also here very carefully, H and the angle that we have here, this small angle that we have here, are also alternating. So if here is H, then H and this angle here are alternating. Now, to find H, we now have this outer angle here to be 1, 2, 3, 1, 2 degrees. We have the inner angle here to be H. We know that angles around a point will give us 360 degrees if you sum all of them. So angles around a point sum up to 360 degrees. So H plus 3, 1, 2 degrees will give us 360 degrees. From here, we can find H, and we have found H to be 48 degrees. Now, we know Z to be 52 degrees, we know H to be 48 degrees, so we can find P. Okay, so we know that P will give us 52 degrees plus 48 degrees, and that will be 100 degrees. Now, the question did not tell us to find P. The question said we should find S. We only brought P because it will help us to find X. Now, we have found P. We know that angles around a point add up to 360 degrees. So, P plus X will give us 360 degrees. We know that P is 100 degrees. So, 100 degrees plus X will be 360 degrees. And X will give us 260 degrees. Thank you for watching this video and all the other videos. Pick more examples on questions of this nature and try your hands on it. Solve more. If you have any problem with them, interact with me on my social media handles and I'll help you to understand them. See you in the next video where we will consider the angle properties of triangles. Bye bye. We are still on the topic plane geometry. In the previous video, we solved some questions using the properties of angles in a parallel line. In this video, we are going to consider the angle properties of triangles. You know that a triangle is a three-sided plane figure. So as we have in this diagram, we have the triangle ABC Then we have the angles M, N, and P. Now these angles M, N, and P are referred to as interior angles. They are the triangles in the angles in the triangle, so they are being referred to as the interior angles of the triangle. Now, what is the property of these interior angles? The interior angles of a triangle sum up to 180 degrees. So if you add all the angles in a triangle, so here if you add M to N to P, you must get 180 degrees. This property is very, very important. The interior angles of a triangle sum up to 180 degrees. Let's consider another property of a triangle. In this slide here, we see that you consider the interior angle. Here, we have extended this line here, line AB, we've extended it to this side. Now we are creating another angle here. Remember there's another one here, but for the sake of the explanation, we are going to use this angle here. I'm going to call this angle here S. S is an exterior angle. Remember, M, P, and N are called interior angles. S is an exterior angle. Now, this X here is called an exterior angle. P and N are called interior opposite angles of X. I'm going to explain that. P and N are called interior opposite angles of X. Now, let's look at this. M here is the interior angle of X. You see, on this line, M is the interior angle and S is the exterior angle. Now, what are the interior angles opposite to M? They are P and N. So we say that P and N here are the interior opposite angle of this exterior angle, which is X. I hope that is clear. P and N here, these angles, angle P and angle N, are the interior opposite angle of the exterior angle here, which is X. Because let's assume that we bring X here, which is the interior angle, we bring it, which is the exterior angle, we bring it to this side. You see, the angles that will be opposite to it are P and N. We are not bringing it here, it's an exterior angle. So we say that P and N are the interior opposite angles of X that we have here. Now, why am I stressing on this? There is this very, very important property that you know. So as I've indicated here, P and N are the interior opposite angles of X. So once again, let's say if we have another angle here, let's assume that we had another angle here. So let's say that we had another angle here, this exterior angle here, and let's call that one B. So if you call this B, we are going to say that M and P are the interior opposite angles of B. I hope that is clear. So M and P will be the interior opposite angles of B, because the interior angle of B is M and the ones opposite to it are P and N. So we say that M and P are the interior opposite angles of B. In the same way, if you continue, if we extend this, sorry, I'm going to clean this here. I want to extend this line so that I draw it for you to see. So in the same way, if we extend this line here, and we create another angle here, and let's say we call that angle, let's call that angle, let's say we call it angle D. If you call this angle here angle D, sorry, my pen is not allowing me to write well. Okay, so if you call that the angle that we form here, if you call that angle D, if you call this angle, the angle that we have, if you call it angle D, you are going to say that M and N will be the interior opposite angle of the angle that we form here, which will be angle D. I hope that is clear. So I'm going to erase the pen here so that we can continue. So here we say that P and N are the interior opposite angle of angle X, as we have here. Now in a triangle, an exterior angle is equal to the sum of its interior opposite angles. I hope this is clear. So here, the exterior angle here, which is x, is equal to the sum of its interior opposite angles. So here, the interior opposite angles are P and N. So the exterior angle, which is x, is equal to the sum of its interior opposite angles, which is P and N. I hope that is clear. So we've learned two properties here. We've learned that the interior angles of a triangle sum up to 180 degrees. We also learned that if you have an exterior angle in a triangle, it's equal to the sum of its interior opposite angles. I've explained what the word interior opposite angles mean. Let's pick some questions and see how to use the property that we just learned. So find the value of the letter in the diagrams below. So here you are supposed to find x, and here you are supposed to find y. Let's pick the first one. So we have A, B, and C. So we have 70 degrees here. Here is x, and here is 130 degrees. Now look at this very well. We can see that we have 130 degrees here. Now its interior opposite angles are x and 70 degrees. The exterior angle here, which is 130 degrees, its interior opposite angles are x and 70 degrees. We know that an exterior angle of a triangle is equal to the sum of its interior opposite angles. So 130 degrees is equal to 70 degrees plus x. If you simplify here, x is going to give us 60 degrees. So you see, it's that simple. This is a very easy way of doing this. Somebody can also pick another way. We know that 130 degrees and this side here, this particular side, I'm going to indicate that with a pen for you to see. 130 degrees and this angle here will be angles on a straight line. So somebody can use that and find the value of the angle that we have here. Now if the person finds the value of the angle that we have here, you can say that the sum of the interior angles of a triangle is 180 degrees. So 70 degrees plus x plus that value will give us 180 degrees. Then you'll be able to find x. But this is easy. Always remember that an exterior angle of a triangle is equal to the sum of its interior opposite angles. So when you do that, you'll be able to find x here to be 60 degrees. Let's consider the next example. So here too, we can see that we have PQR as the triangle. Then we have y here. Now looking at the position of the y, here, its interior opposite angles are 30 degrees and 40 degrees. We know that an exterior angle of a triangle is equal to the sum of its interior opposite angles. So y will give us 30 degrees plus 40 degrees, and y is 70 degrees. Thank you for watching this video on the angle properties of triangles. We are going to continue and learn more about the properties of triangles in the next video. Bye bye.
We are still on the topic plane geometry. In the previous video, we considered two properties of angles in a triangle. We saw that the interior angles of a triangle add up to 180 degrees, and an exterior angle of a triangle is equal to the sum of its interior opposite angles. In this video, we are going to consider types of triangles and their properties. So let's begin with the first type of triangle, the equilateral triangle. If you watch the video on mensuration, we did explain the equilateral triangle and its properties. In this video, we are going to consider the angle properties of an equilateral triangle. We know that this is an equilateral triangle because there is this line here, this line here, and this line here, showing that the length of this side and that side and that side are equal. So for equilateral triangles, all the sides are of equal length, and all the interior angles are equal. So the interior angle of an equilateral triangle is 60 degrees, because 60 degrees plus 60 degrees plus 60 degrees will give us 180 degrees. So if you take an equilateral triangle, all the sides are equal. And you know that using the lines that have been used here. So we have this line here, this line here, and this line here, showing that all the sides are equal. Then the angles are also equal, as it can be seen here. The next type of triangle we are going to consider is what we call the isosceles triangle. For an isosceles triangle, two sides are of equal length. So when you, in this diagram, you can see that we have one line here and one line here, meaning that this side and this side are of equal length. But when you come to this side, the lines are two, showing that the length here is different from the one that you have here and the one that you have here. So for an equilateral triangle, you see that there was only one line here, and another line here, showing that all the lengths are the same. When you consider the isosceles triangle, there is one line here and one line here, showing that this side and this side, the lengths are the same, but this side has a different length, so the line here is 2. Now, another property of an isosceles triangle is that two interior angles are equal. Now, what are these two interior angles? You will see that the sides that are the same, the angles formed at their bases are also the same. So this side is equal, the length of this side and the length of that side is equal. The angle that will be formed at the base of those sides are the same. So the angle formed here, if that angle is x, the angle formed at this side will also be x. So the two sides that are the same, the angle that are formed at their bases will also be the same. So the angle formed here will be x, and the angle formed here is also x. I'm just using the x to represent the angle that will be there. So all you need to know about isosceles triangle is that two sides are of equal length, then two interior angles are also equal. The interior angles that are equal are the angles formed at the base of the two sides that are equal. Let's consider the next type of triangle called the scalene triangle. All the sides have different lengths, all the interior angles are different. So you can see that there is one line here. When you come here, there are two lines. When you come here, there are three lines, showing that the length of this side and the length of this side and the length of that side are all different. So for an isosceles triangle, there's one line here and one line here, showing that the length of this side and the length of that side are the same, but the length of this side is different, so two lines are used to show. When you come here, the length of this side and the length of that side and the length of that side are different, so you use one line here, you use two lines here, then three lines here. Also, all the interior angles are different, so the angle formed here will be different, the angle formed here will be different, and the angle formed here will also be different. When you have such a triangle, we say that you have a scalene triangle. Let's consider the last type of triangle that we'll be considering in this video, called the right-angled triangle. For a right-angled triangle, all the sides are different. Just like for scalene, all the sides are different. For right-angled triangle too, all the sides have different lengths. One unique thing about the right-angled triangle is that one interior angle is 90 degrees. So for right-angled triangles, one interior angle is 90 degrees. So just as you have here, I told you in a previous video that if you see this sign here, it means that a 90 degrees or a right angle. So this is forming a right angled triangle. All the sides are of different lengths, but one of the interior angles is 90 degrees. Whenever you have that, we say that you have a right angled triangle. Now let's use these properties that we've learned about triangles to solve some questions. Let's pick the first question. We are being told to find the value of the letter in the following diagrams, and we have been given our first diagram. So straight away, looking at this diagram, we can see that triangle THG is an isosceles triangle. The reason being that there's one line here and one line here showing that the length of this side and the length of that side are the same. One thing that we've learned about isosceles triangles are that two sides are the same, then the angles formed at the basis of these two sides are also the same. So if this side is P, then we can say that angle TGH, that is angle TGH, this side will also be P. So you see, we've used the property to find the angle that is here. Because this is an isosceles triangle, two sides are the same. That is what the question is telling us. Using this bar here and this bar here, it's showing us that this side and this side are the same. Now when you have that, we say that the angles formed at their basis will also be the same. So if this side is P, then this side is also P. So now we have the interior angles of this triangle. We have here to be P, P, and 50 degrees. The question told us to find the letter here. The letter here is P, so we can find P. We know that the interior angles of a triangle sum up to 180 degrees. So if we add P to 50 degrees, we should get 180 degrees. P plus P will give us 2P. So we have 2P plus 50 degrees is equal to 180 degrees. 2P will be 180 degrees minus 50 degrees, which is 130 degrees. You divide both sides by 2, you are going to get P to be equal to 65 degrees. So you see, from this question, we've used the property of an isosceles triangle to find the value of P. Let's take another question. Now looking at this diagram, what can we see? We can see straight away that we are seeing this sign here, which means that this triangle ABC, is a right angled triangle. We know that for right angled triangles, the angle that you have this sign here is 90 degrees, which means that angle ABC is 90 degrees. So we have here to be 90 degrees, we have here to be 50 degrees, and we are supposed to find the letter here, which is Y. We know that the interior angles of a triangle sum up to 180 degrees, so we can say that Y plus this side here, which is 90 degrees plus 50 degrees, will give us 180 degrees. So Y plus 140 degrees will give us 180 degrees. So we can say that Y is equal to 180 degrees minus 140 degrees. So Y is 40 degrees. So if you have also used the property of a right angled triangle to find the value of Y in this question. Let's consider our last question in this video. So we have triangle PQR. The interior angle here is 50 degrees, the interior angle here is 60 degrees, and you have been given here to be X. So you are supposed to find the value of X. So straight away from here, we have been given all the interior angles, so we can add them and equate it to 180 degrees, because we know that the interior angles of a triangle sum up to 180 degrees. So X plus 50 degrees plus 60 degrees will give us 180 degrees. This will give us S plus 110 degrees to be equal to 180 degrees. So X will be 180 degrees minus 110 degrees, which will be 70 degrees. So looking at this diagram or this triangle very carefully, you see that this angle is 50 degrees, here is 60 degrees, and X is 70 degrees. So all the interior angles are different. So this is an example of a scalene triangle, because the interior angles are all different and the sides are also different. Thank you for watching this video. Pick more examples on triangles. In the next video, we are going to use the properties of angles in a triangle that we've learned in the previous video and this video to solve more questions. Bye bye. We are still on the topic plane geometry. In the previous video, we considered the types of triangles and the properties of these triangles. In this video, we are going to use the properties of angles in a triangle that we have learned to solve some questions. So let's begin by picking the first question. Find the value of the letter or letters in the following diagrams. And we have been given our first diagram here. So I'm going to shift it to this side so that we can solve it. As I've been saying, whenever the question is given to you, consider the question very carefully, look at the diagram well, then record the properties that you've learned, then pick the one that will help you to solve the question. So let's consider this diagram that we have here. What can you say about it? We can see that triangle ABC is an isosceles triangle. There is one bar here and one bar here, showing that line AC and line BC are equal. So if this is an isosceles triangle, what we know is that the angles formed at the basis of the sides that are equal are also equal. So if this side here is B, from the properties of isosceles triangles, we know that this side here will also be B. So if triangle ABC is an isosceles triangle, then angle BAC is also B. I hope that is clear, right? Because this triangle ABC is an isosceles triangle, if this side here is B, then this side here is also going to be B. So we found here to be B, and we have here the question gave it to us as B. Now, if you're able to find the angle here, if you're able to find this angle here, the interior angle here, then we can use this, the sum of the interior angles of a triangle summing up to 180 degrees to find the value of B. And to help us find that, we have been given this outer angle here. We have been given the whole angle here, the one out here, to be 278 degrees. So if we assume that the interior angle here is N, we can use this property, the property that angles around a point sum up to 360 degrees to find N. Because if you assume this place to be N, it means that if you add N to 278 degrees, angles around this point C should give us 360 degrees. So you can use that property to find N. So what we are going to say is that angles around a point sum up to 360 degrees. So we have assumed this place to be N. So we are going to say that N plus 278 degrees will give us 360 degrees. From here, we can find N to be 82 degrees. So now we have been able to find this place here to be 82 degrees. Here is B, here is B. So we can add the interior angles and equate them to 180 degrees, because we know that the interior angles of a triangle sum up to 180 degrees. So B plus N will give us 180 degrees. We have already found N to be 82 degrees. B plus B will give us 2B, so plus N, which is 82 degrees, is equal to 180 degrees. 2B will be equal to 180 degrees minus 82 degrees. So 2B will give us 98 degrees. You divide both sides by B, and we divide both sides by 2, and B will give us 49 degrees. So you see, when the question is given to you, look at it very well, then record the properties that you know and use the one that will help you to solve the question. Here, we use the fact that this triangle is isosceles to find this side here to be B. Then to help us find it, we saw that we have to find this interior angle here. We have been given this outer angle here, so all we needed to do is that we add the value here to the one that you have outside here, then that will give us 360 degrees. We use that to find N here. Then we use the fact that interior angles of a triangle sum up to 180 degrees to find the value of B. Let's take another question. We have this diagram here, and we are being told to find the letters. So we are finding A, B, and C. Now, let's go. A, B, and C. Look at this diagram very, very carefully. What can you see? Straight away, I can see that triangle BDC. This triangle BDC is an isosceles triangle. Look at it. There is this line here and there is this line here, showing that this side here and this side here are equal. So if this side here and this side here are equal, and here is 48 degrees, then what it means is that this side here will also be 48 degrees. I hope that is clear. So triangle CBD or BDC, as I said, triangle
CBD is an isosceles triangle. So angle CBD, which is this angle here, is 48 degrees. I hope that is clear, because triangle CBD is an isosceles triangle. It means that this side and this side are equal. So if here is 48 degrees, then here will also be 48 degrees. Now we can, because we are found here to be 48, here is 48 and here is C, we can use the fact that interior angles of a triangle sum up to 180 degrees to find A, because we have triangle CBD, we have this interior angle, we have this, and we have this letter here, so we can find it. So we can say that 48 degrees plus 48 degrees plus A will give us 180 degrees. So from here, 48 plus 48 will give us 96. So we have 96 degrees plus A to give us 180 degrees. So if you simplify, A is giving us 84 degrees. So we found A. Let's move on. What can you see again? I can also see that this angle here, angle C, and this 48 degrees here are on a straight line. We know that angles on a straight line add up to 180 degrees. So if I add C to 48 degrees, I must get 180 degrees. So from here, C will give us 180 degrees minus 48 degrees, and C will give us 132 degrees. So you see, I've been able to find that. Now let's continue to find the last one, which is B. I know that vertically opposite angles are equal. Now look at it very well. This angle here that you have here, B, is vertically opposite to this angle here, angle ADB. Is vertically opposite to B that we have here. So if here is B, because we know that vertically opposite angles are equal, this side here will also be B. I hope that is clear. Vertically opposite angles are equal. So if here is B, then this angle here will also be B. Now look at this. We know here to be 20 degrees. We have found C to be 132 degrees. We know that the interior angles of a triangle sum up to 180 degrees. So 20 degrees plus C plus B, which are the interior angles of the triangle ADB, must give us 180 degrees. So interior angles of a triangle sum up to 180 degrees. So we can say that 20 plus C plus B will give us 180 degrees. So C is 132 degrees as we found in the previous slide. So 20 plus 132 degrees plus B is equal to 180 degrees. 20 plus 132 will give us 152. So plus B will give us 180 degrees. B, if you simplify, you are going to get 28 degrees. So you see, when the diagram is given to you, all you need to do is to record the properties that you've learned. So make sure that you know the properties. Record the properties that you've learned, then look at the diagram and see which property that you can apply to help you solve the question. Thank you for watching this video about angles in a triangle. See you in the next video, where we will pick more examples on angles that are in a triangle. Bye bye. We are still on the topic plane geometry. In the previous video, we solved some questions on triangles. In this video, we are going to solve 2 more questions. So let's begin by looking at the first one. We are being told to find the value of the letter or letters in the following diagram. We have only one letter in this diagram, which is the letter S, so we are finding the value of S. So let's begin with the solution. Now we can see that from this diagram, triangle ABC and triangle ACD are all isosceles triangles. So with triangle ABC, you can see that the angle here and the angle here will be the same. And for triangle ACD, the angle that will be formed here and the angle that will be formed here will also be the same, because they are isosceles triangles. Now because we have a certain angle with a value here, we are going to begin our solution from this side so that it will be very simple for us. Now let's begin. Because triangle ACD is an isosceles triangle, we can say that angle CDA and angle CAD, which means this side and this side are equal. So if this side is M, this side is also going to be M. We are beginning from this side because we have a value here. You can see from here that there is no value here, so it will be difficult to begin from this side. Because we have a value here which is 145 degrees, it is easier to begin from here. Now, with 145 degrees and M here, we can find the value of M, because we know that angles on a straight line add up to 180 degrees, and M and 145 degrees are on a straight line. So M plus 145 degrees will give us 180 degrees. We simplify and M will give us 35 degrees. So we have here to be 35 degrees and here to be 35 degrees. So we can find the other interior angle of this isosceles triangle. So let's assume that this side here is this side here is N. We know that interior angles of a triangle add up to 180 degrees. So M plus N will give us 180 degrees. M is 35 degrees, so we are having 35 degrees plus 35 degrees plus N to give us 180 degrees. So 35 plus 35 will give us 70. So we are having 70 degrees plus N is equal to 180 degrees. So we simplify and N is giving us 110 degrees. So we have here to 110 degrees. So we see that we began from here and we are working towards the triangle ABC, which has the letter S in it. Now we are able to find the side here. Now because triangle ABC is an isosceles triangle, angle ABC and angle ACB are equal. So if this side is S, this side is also going to be S. We know the value of N, so we can use S and N and the property that angles on a straight line add up to 180 degrees to find the value of S. Because angles on a straight line add up to 180 degrees, you can say that S plus N will give us 180 degrees. We know the value of N, right? It's 110 degrees. So S plus 110 degrees will give us 180 degrees. So you simplify and S is giving us 70 degrees. Remember, the question is not telling us to find the value of this side here, which is S. We are finding the value of S here. So with this, we know that interior angles of a triangle add up to 180 degrees. So S plus X is equals to 180 degrees. We have found X to be 70 degrees. So 70 degrees plus 70 degrees plus X here will give us 180 degrees. We simplify, we are getting 140 degrees plus X is equal to 180 degrees. So S will give us 40 degrees. So we see that from this diagram, we have used the property of isosceles triangles to find the value of S. So whenever the question is given to you, you study the diagram very carefully, then use the properties of triangles that you've learned to solve the question. Let's consider the next one. So we have this diagram here and we are supposed to find the value of S here. Now you can see that this is a quadrilateral, a four-sided figure. So P, R, Q, S. Now to turn this into a triangle so that we can solve, I'm going to draw another line here, as you can see here. Now you see, as soon as I draw this line here, you can see that we have triangle PSQ and triangle PRQ. Let's begin by tackling the triangle inside here, then we move on to the outside triangle. So triangle PSQ is an isosceles triangle. You see that there is this line here and this line here, showing that this side and this side are the same. So it means the angle that will be formed here and the angle that will be formed here will be equal. So triangle PSQ is an isosceles triangle. So we can say that angle SPQ and angle SQP, which means that this side and this side are equal. So if here is A, here is going to be A. I hope that is clear, because triangle PSQ forget about the lines here and the angle here. We are dealing with triangle PSQ, and because it's an isosceles triangle, if here is A, here is going to be A. Now we can find A. We know that the interior angles of a triangle sum up to 180 degrees, so A plus 95 degrees will give us 180 degrees. A plus A will give us 2A plus 95 degrees will be 180 degrees. So 2A will be equal to 180 degrees minus 95 degrees, which is 2A is equal to 85 degrees. We divide both sides by 2, and A is giving us 42.5 degrees. So you have found this side to be 42.5 degrees. You have also found this side here to be 42.5 degrees. Remember, the question did not tell us to find A. We even introduced A so that you'll be able to find S. So we move on to the bigger triangle, which is triangle PRQ. That's what we move on to. Now let's consider triangle PRQ. We can also see that triangle PRQ is an isosceles triangle. Triangle PRQ is an isosceles triangle because you can see from here that there are two lines here and there are also two lines here, meaning that line PR and line QR have the same length, and we know that in isosceles triangles two sides are of the same length. So if two sides are of the same length, then it means that triangle PQR or PRQ is an isosceles triangle. And if it's an isosceles triangle, then angle QPR, so QPR, and angle RQP, which angle QPR is this whole angle here, S plus A. Angle RQP will be this whole angle here. Now because it's an isosceles triangle, this side and this side must be the same. So if here is A and here is A and here is S, then this side here must be S. I hope that is clear. Because triangle PQR is an isosceles triangle, if this side here is A and this side here is A and here is S, then here must also be S, because triangle PQR is an isosceles triangle. From here, we can proceed to find the value of S. We know that the interior angles of a triangle sum up to 180 degrees. So we are now considering triangle PQR. So it means that 25 degrees, which is this angle here, plus when you come here, we have S plus S and A. So S plus A plus S plus A must give us 180 degrees. So here we are considering the bigger triangle. In the previous slide, in finding A, we considered this smaller triangle. This time, we are considering the bigger triangle here, which is also an isosceles triangle. So we have 25 degrees plus S plus A plus S plus A will give us 180 degrees. We have found the value of A. A is 42.5 degrees. So we have 25 degrees plus S plus 42.5 degrees plus S plus 42.5 degrees will give us 180 degrees. We add all the numbers and we are getting 110 degrees. So S plus S will give us 2S. So 2S plus 110 degrees will give us 180 degrees. 2S will give us 180 degrees minus 110 degrees. 180 minus 110 is 70, so 2S will give us 70 degrees. We divide both sides by 2 and we are getting S to be 35 degrees. So from here to we have used the properties of an isosceles triangle to find the value of S. Thank you for watching this video. Pick more examples on triangles and try your hands on them. If you have any problem or any difficulty in solving it, you can interact with me on my social media handles and I'll help you to solve it. See you in the next video where we'll solve more questions on angles in a triangle. This time, some of the lines in the triangle will be parallel lines. Bye bye. We are still on the topic plane geometry. In the previous video, we saw some questions on angles in a triangle. In this video, we are going to solve some questions on angles in a triangle that contain parallel lines. So let's pick some questions and see how to go about this. So parallel lines in a triangle. You are being told to find the value of the letters in the following diagram. Here we have just one letter, which is the letter Q. So we are going to find the value of the letter Q in this diagram. Now you can see from this diagram that this is a parallel line. PQ is also a parallel line. Now because we have parallel lines, we can use the following properties. The properties about alternate angles, the properties about co-interior angles, and the properties about corresponding angle. Remember that on the video on parallel lines, we said that we can use this in the video on parallel lines, we said that we can use these properties if and only if we have parallel lines. Here there are parallel lines in the triangle, so we can use these properties. So we are going to add these properties to the properties about triangles that we already know to solve the question. So let's consider this diagram here. We have triangle PQR. We have this parallel line here. PQ is also a parallel line. Now triangle PQR is an isosceles triangle. You can see that this side and this side are equal. So the angle that is formed here and the angle that is formed here will also be equal. So triangle PQR is an isosceles triangle. So angle RPQ and triangle PQR, which means that this side and this side are equal. So if here is N, this side will also be N. Now let's look at it very well. How do we find these sides so that we'll be able to find Q? We can see from here that looking at the position of 50 and N, 50 and N are alternate angles, and alternate angles are equal. So N is equal to 50 degrees. So we have used the property of alternate angles because we have parallel lines. We can now use the property of alternate angles. So we have used that to find N. So we have found this place to be 50, and because it's an isosceles triangle, if here is 50 degrees, here is also 50 degrees. So we have here to be 50 degrees, we have here to be 50 degrees, here is 2Q. We can add them and equate it to 180 degrees so that we'll be able to find Q. We know that interior angles of a triangle add up to 180 degrees. So N plus 2Q will give us 180 degrees. We know that N is 50 degrees, so 50 degrees plus 50 degrees plus 2K will give us 180 degrees. 50 plus 50 is 100, so 100 degrees plus 2K is equal to 180 degrees. 2K will be equal to 180 degrees minus 100 degrees, so 2, you simplify from here and K is giving us 40 degrees. So you see here, because we have parallel lines, we can now use alternate angles, co-interior angles, and corresponding angle. Here, what will help us was the alternate angles. Here what will help us was the alternate angles. So we used the alternate angles to find the value of N. Then, because this triangle is an isosceles triangle, we also use that property to find the angle here and the angle here. Then we use the property that interior angles are equal to find the value of Q. So when you have the question, just record the properties that you have, look at the appropriate one that will help you to solve the question, and use those properties to solve the question. Let's consider the next diagram. So we have this diagram here. We have the triangle ABC. Then we have a parallel line here. We have this parallel line here. So here, line AC is our transversal. If you watch the video on parallel lines, you understand that line AC is our transversal. So we are supposed to find the value of Y. So we are going to find the value of Y. Now look at something very carefully. Here we can see that 105 degrees or 105 degrees, and the angle that will be formed here, the empty space here, are co-interior. So if we assume that this place here is H, we know that co-interior angles add up to 180 degrees. So H plus 180 degrees, H plus 105 degrees will give us 180 degrees. So H will be equal to 75 degrees. Now we have been able to find here to be 75 degrees. We already know this side here to be 50 degrees. Y, H and 50 degrees are angles on a straight line. So we can add that and equate to 180 degrees because angles on a straight line sum up to 180 degrees. So 50 degrees plus H, which is 75 degrees, plus Y, which we are looking for, will give us 180 degrees. 50 plus 75 degrees plus Y equals to 180 degrees. We simplify that and Y is giving us 55 degrees. So as soon as you write this and you write your equation here, it turns to linear equation, and you watch the video on linear equation, you see that this is basic linear equation, and you simplify it. So here when we do the simplification, Y is giving us 55 degrees. So here too, we use the property of co-interior angles because we have parallel lines. We can use that. So we use that to find the value of the angle here. Then we used angles on a straight line to solve for this. Somebody can also choose to do it in a different way. Always study the diagram, then pick the properties that will help you to solve the question. Let's look at the last question in this video. We are supposed to find the value of S here. So let's look at, this is the triangle ABC. So we have triangle ABC here and we are finding the value of S. So AC is a parallel line, looking at the arrow. Then B, this line here is also a parallel line. So we have this parallel line here, we have this parallel line here. Now this will be a transversal crossing it. So this parallel line here and this parallel line here, and this is a transversal. Now looking at the diagram very carefully, we are going to assume that this angle here, the empty angle here, we are going to assume that is G. Now consider the position of G and 81 degrees, and you will see that G and 81 degrees are alternate angles. Look at it very carefully. It goes this way, comes this way, then this way. So the angles here, G and 180 degree and 81 degrees, are alternate angles. What do we know about alternate angles? Alternate angles are equal. So what that means is that G is also equal to 180 degrees. Now if G is equal to 180 degrees, you know that 56 degrees, G and S are angles on a straight line. So 56 degrees plus G plus X will give us 180 degrees because angles on a straight line add up to 180 degrees. So we know G to be 81. So 56 degrees plus 81 degrees plus X will give us 180 degrees. From here it is linear equation. 56 plus 81 is 137. So 137 degrees plus S will be 180 degrees. We simplify this and S is giving us 43 degrees. So here too, we use the property of alternate angles, and we also use the property of angles on a straight line to find the value of S. Try using different properties and see if you can also find the value of S. Thank you for watching this video on finding the values of angles in a triangle that contains parallel lines. In the next video, we will pick more examples on finding the value of angles in triangles that contain parallel lines. Bye bye. We are on the topic plane geometry. In the previous video, we solved some questions on finding the value of angles in triangles that contain parallel lines. In this video, we are going to take two more examples. So let's pick the first one. We are being told to find the value of the letter or letters in the flowing diagram, and we have only one letter here, which is the letter S. So we are going to find the value of this letter S. Now let's study the diagram very carefully. We can see that ST here or TS here is a parallel line, then QR is also a parallel line. So we have this parallel line here, we have this parallel line here. Now we have this angle here, then
which is x. We have this one here, which is 35 degrees. So QRP, we have one interior angle to be 35 degrees. We have the other one to be s, and we are supposed to find the value of this s. Now this is a parallel line, this is a parallel line. So this one is a transversal, this one is also a transversal, this line is also a transversal. So let's begin by solving the question. Now what do? We can see from here that if I name this angle here I, this angle here, if I name it I, looking at the position of 52 degrees and I can say that I and 52 degrees are corresponding angles. Now look at it very well. I is below here, I is below here, 52 degrees is also below here. This is a parallel line, this is a parallel line, this is a transversal. If you watch the video on parallel line, properties of parallel lines, angles in a parallel lines, you can see that I and 52 degrees are corresponding angles. And we know that corresponding angles are equal, so I is equal to 52 degrees. I hope that is clear. Now we found I to be 52 degrees. Looking at this diagram also very carefully, we can also see that I and this side here are vertical opposites. So I and this interior angle here of the triangle are vertical opposites. So if here is I, then this interior angle is also I. We have found I to be 52 degrees. So we have here to be 52 degrees. Here is 35 degrees. So we can now find S. We know that the interior angles of a triangle add up to 180 degrees. So S plus I plus 35 degrees will give us 180 degrees. We found I to be 52 degrees. So S plus 52 degrees plus 35 degrees will give us 180 degrees. S plus 87 degrees will give us 180 degrees. You simplify this and S is giving us 93 degrees. So we be able to find the value of S to be 93 degrees. So here too, we use corresponding angles and the fact that interior angles of a triangle sum up to 180 degrees to solve this question. As I said, you can use any of the properties. So here, try your hands on using other properties to see if you'll be able to solve the question or to be able to find the value of S. So since we have parallel lines and transversal, try using alternate angles or co-interior angles and see if you can find a way of finding the value of S. You always have more than one way of solving the question. Let's consider the next one. We are being told to find the value of Y. So here, the letter here is Y, so we are going to find the value of Y. I'm going to shift the diagram here so that you can write our solution at the side. Now you can see that line AB is a parallel line. Line DE is a parallel line, but these parallel lines, this one ends just here. So to help us solve this, we are going to employ an auxiliary parallel line, a helping parallel line. So we are going to continue this parallel line. Now you see, if you continue this parallel line here, we have this parallel line, we have this one. So this line here, this small line here, will serve as a transversal for us. Now we have this one here as our transversal. So we have parallel lines and a transversal, so we can move on with our solution. Now let's assume that this interior angle that will be created, you see that this and this point will form a triangle. So we now have a triangle here. So we are going to call this interior angle here N. Now we can find the value of N. We know that angles on a straight line add up to 180 degrees. So 110 plus N will give us 180 degrees. We simplify and N will give us 70 degrees. So we found this interior angle to be 70 degrees. Now I'm going to call this exterior angle here M. I'm going to call this exterior angle here M. Now look at the position of M and 120 degrees. Remember that this is a parallel line, this is a parallel line, and this is a transversal. If you look at it very carefully, you see that M and 120 degrees are corresponding, and corresponding angles are equal. So
m will be equal to 120 degrees. I hope that is clear. So you have been able to find n, you have been able to find m. Remember that we introduced the m and n. We are just introducing them so that we'll be able to find the value that we want to find. We'll be able to find the letter that you want to find, which is y. So we have found n to be 70 degrees, we have found m to be 120 degrees. Now, what property can we use to find y? We now know n, we now know m. We know that an exterior angle of a triangle is equal to the sum of its interior opposite angles. We know this property about triangles. Now, this B, C, and this point here, together we have a triangle here. Now we have this exterior angle here. The interior opposite angles of this exterior angle are n and y. If you watch the first video on triangles, I explained what interior opposite angles are. So the interior opposite angles of this exterior angle here, which is m, are n and y. And we know that an exterior angle in a triangle is equal to the sum of its interior opposite angles. So what this means is that n plus y is equal to m, because n and y are the exterior opposite angles of m, are the interior opposite angles of m. So n plus y will give us m. Now we have found n, we have found m, so you can find y. N is 70 degrees, m is 120 degrees. So 70 degrees plus y will give us 120 degrees. So you simplify this and you are getting y to be 50 degrees. Once again, this is the method that I chose to solve the question. There are so many other ways of solving this question. So try using other methods and using other properties to see if you can be able to find the value of y. Thank you for watching this video on angles in triangles. Pick more examples and try your hands on them. As you can see, there's always more than one way of solving the question. So try your hands on different ways so that you'll be conversant with the properties. When you have the question, look at the question very well, study it, then apply the properties that you've learned, which will help you to be able to solve the question. See you in the next video, where we look at the angle properties of quadrilaterals. Bye-bye. We are still on the topic plane geometry. In the previous video, we learned how to find the angles in a triangle using the properties of a triangle. In this video, we are going to learn the angle properties of a quadrilateral and pick some examples on how we can use these properties to find angles in a quadrilateral. So what is a quadrilateral? A quadrilateral is a plane figure with four sides. In the previous video, we said that a triangle is a plane figure with three sides. So any plane figure with four sides is called a quadrilateral, just as any plane figure with three sides is called a triangle. I hope that is clear. So a plane figure with three sides is a triangle. A plane figure with four sides is a quadrilateral. If you watch the video on mensuration, we considered different types of quadrilaterals: squares, kites, rhombus, and we looked at the properties of these. In this video, we are going to consider the angle properties of a quadrilateral as a whole. That's what we are going to consider. So let's say we have this quadrilateral here. We have this four-sided plane figure. So PQRS is a quadrilateral. Now, what are the angle properties of this quadrilateral? The main thing you have to know about quadrilaterals is that the sum of the interior angles of a quadrilateral is 360 degrees. In the previous video on triangles, we said that the sum of the interior angles of a triangle is 180 degrees. For a quadrilateral, if you sum the interior angles, you are supposed to get 360 degrees. So what this means is that, let's say I call this angle here angle A. I call this one here angle B. I call this one here angle C. And call this one here angle D. The sum of the interior angles of a quadrilateral is equal to 360 degrees. What this means is that A plus B plus C plus D will give us 360 degrees. This is the main property of angles in a quadrilateral. Now let's pick some examples and see how we can use these properties to solve some questions. So let's pick the first one. Find the value of the letter in the following diagrams. So with this diagram, we are supposed to find the value of S here. Now what do we know about this? So this is going to be the solution, not the question. So I'm going to cancel this here. Okay, so this is the solution. The question was what we had on the previous page. So let's begin with the solution. We know that the sum of the interior angles of a quadrilateral is 360 degrees. So if we add all the angles in this quadrilateral, you should get 360 degrees. So S plus 140 degrees plus 70 degrees plus 65 degrees will give us 360 degrees. We do this simplification and S will give us 85 degrees. So as soon as you write this, the rest is linear equation. You add the numbers, then you make S the subject. We do that and we are getting S to be 85 degrees. So we have used this property of a triangle of a quadrilateral to find the value of S. Let's consider the next question. So here we are finding the value of S. Now we know that the sum of the interior angles of a quadrilateral is 360 degrees. So what this means is that if we add 2S to S to S plus 10 to S minus 50, we are supposed to get 360 degrees. So we add everything, all the interior angles of the quadrilateral, and we equate that to 360 degrees. So S plus S plus S, 2S plus S plus S plus S will give us 5S. 10 degrees minus 50 degrees will give us minus 40 degrees. Then we equate this to 360 degrees. So we are going to get 5S is equal to 360 plus 40 degrees. So 5S will equal to 400 degrees. We divide both sides by 5 and we are getting S to be 80 degrees. So we have S to be 80 degrees. So we know that the interior angles of a quadrilateral add up to 360 degrees. So we add all the interior angles and we equate it to 360 degrees. Let's consider the next example. Now we have this quadrilateral here, M, N, O, P. So this is the quadrilateral and we are supposed to find the value of S and Y. We are supposed to find the value of S and Y. Now we can see from here that there are two isosceles triangles in this quadrilateral. So if you take the triangle PON, it's isosceles because we have this bar here and this bar here, showing that the length of PO and the length of NO are equal. So if this angle here is S, then this side here will be S. That is why the point here is telling us that then angle PNO, so PNO, which is this angle here, is equal to angle NPO, which is this angle here. So because triangle PON is an isosceles triangle, if this angle here is S, then here must also be S. I hope that is clear. Even though this is a quadrilateral, the question has divided it into two triangles for us, and we are seeing that one of the triangle here, angle PON, is an isosceles triangle. So we can use the properties of isosceles triangles to find the value. So just as I said, whenever the question is given to you, study the diagram very carefully. Then the properties that we've learned, look at the one that applies to the question that has been given to you, then you use it. So here we have seen that triangle PON is an isosceles triangle. We know the properties of isosceles triangle. Two sides are equal and the angles formed at the base of those two sides are also equal. So if this place is S, because PON is an isosceles triangle, this angle will also be S. I hope that is clear. So we have S here, we have X here, we have 70 degrees. PON is a triangle, so we can use the properties of interior angles of a triangle to find the value of S. We know that the interior angles of a triangle sum up to 180 degrees. What this means is that S plus 70 degrees will give us 180 degrees. S plus S is 2S plus 70 degrees is equal to 180 degrees. We simplify this, we are getting 2S is equal to 110 degrees. You divide both sides by 2 and S is giving us 55 degrees. S is given as 55 degrees. So we found the value of X. Now let's move on to Y. Now consider the triangle PMN. Look at it very well. Let's consider triangle PMN. Now you can also see that triangle PMN is also an isosceles triangle. We have two bars here, then we also have two bars here, showing that the length of the length of MP and the length of MN are equal. So there are two bars here, then there are two bars here, indicating that the length of MP and the length of MN are equal. So if two sides of a triangle are equal, it means that the triangle is an isosceles triangle. And because triangle MPN is an isosceles triangle, the angle formed at their bases will also be the same. So the angle formed at Y and the angle formed at 65 degrees will be the same. So if here is 65 degrees, then it means that Y is also 65 degrees, because triangle PMN or triangle MPN is an isosceles triangle. The angle formed here and the angle formed here will be the same. So Y is equal to 65 degrees. So angle MPN, so MPN, which is Y, is equal to angle PNM, which is 65 degrees, because triangle PMN is an isosceles triangle. I hope that is clear. So we have found the value of X, we found the value of Y. We have another letter here, which is Z. Now how do we find the value of Z? Let's look at this very carefully and consider triangle PMN again. We see that Z here is an exterior angle. If you look at it very well, you will see that Y and 65 degrees are the interior opposite angles of this exterior angle, which is Z. What do you know about an interior opposite angle of a triangle? We know that an exterior angle of a triangle is equal to the sum of its interior opposite angles. We have an exterior angle here, which is Z. We know its interior opposite angles to be Y and 65 degrees. We found the value of Y, so we can find Z from there. What this means is that Z or Z is equal to Y plus 65 degrees. We know that Y is 65 degrees, so Z is equal to 65 degrees plus 65 degrees, which will give us 130 degrees. This is one way of solving the question. Somebody can also choose another way of solving it. As I said, there can be so many ways of solving the question. The most important thing that you have to do is that you study the diagram very well, you record the properties that you've learned, then go through the properties and see which one will help you to solve the question. Then you use that property. Now we are going to consider this. We can see from here that in this quadrilateral A, B, C, D, we have some parallel lines here. So because we have parallel lines, we can use co-interior angles, we can use alternate angles, and we can use corresponding angles. Together with the other properties that we know, we can use all of them to solve the question here. So let's study the diagram very well. Now we are supposed to find X, we are supposed to find Y, and we are supposed to find M. Now which one do you want to start with? We know that alternate angles are equal. Now let's look at the diagram very well. This is a parallel line, BC is a parallel line, AD is also a parallel line. So it means that this line here, this diagonal here, if you watch the video on mensuration, you will see that this line is called a diagonal. Line AC is called a diagonal. If you look at this diagonal very well and look at the parallel line BC and parallel line AD, you can see that M and 40 degrees are alternate angles. Now look at it very well. This is the parallel line, this is the transversal, then this is the parallel line here. So the angle formed here and the angle formed here will be alternate angles. What do you know about alternate angles? We know that alternate angles are equal. So M is equal to 40 degrees. So we've used the property of alternate angles to find the value of M. Now let's look at the diagram also very well. We can also see that S here, this S here, And the angle that will be formed here are also alternate angles. So angle ACD, which is this small angle here, the small angle that we have here, is also equal to S, because if you look at it very well, this is a parallel line, this is a parallel line. Now, considering this one too, DC is a parallel line, AB is a parallel line. So looking at this is the parallel line here, this one is the transversal, then this is the other parallel line. So the angle formed here and the angle formed here are equal because alternate angles are equal. So if here is S, this side here is also going to be S. So you see, you have to be conversant with the alternate angles, corresponding angles, co-interior angles, on all the other properties. You study the diagram and you see the one that will help you to solve. So here we are using alternate angles, and we have figured out that if here is S, then this side is also S because they are alternate angles. We have S, we have 120 degrees, we have 40 degrees. ADC is a triangle. We know that the sum of the interior angles of a triangle is 180 degrees. So we can add 40 to 120 degrees to S and equate it to 180 degrees so that you can find S. So S will give us, this is going to give us S plus 160 degrees is equal to 180 degrees. We simplify and S is giving us 20 degrees. So S is giving us 20 degrees. So we have S, we have M. We are now left with finding Y. Now, because we have S, we have M, if you want to find Y, we know that ABC is a triangle. The sum of the interior angles of a triangle add up to 180 degrees. So S plus M plus Y will give us 180 degrees. We know S to be 20 degrees. We know M to be 40 degrees. So we add that to Y and you equate it to 180 degrees so that you'll be able to find Y. So we simplify this. We are going to get Y plus 60 degrees is equal to 180 degrees, and Y will give us 120 degrees. Y is giving us 120 degrees. So all that you need to do is to study the diagram, then apply the properties that you've learned. If you see parallel lines in the diagram, it means that you can use corresponding angles, alternate angles, co-interior angles, together with the other properties that you know to solve the question. This is one way of solving the question. You can also try to use another way to solve the question and see if you are going to get the solution or the answers that you got in this video. Thank you for watching this video. To understand this very well, pick more examples and try your hands on them. If you have any difficulty in solving the question, interact with me on my social media handles and I'll help you to solve it. See you in the next video, where we are going to consider the angle properties in a polygon. Bye bye. We are on the topic plane geometry. In the previous video, we looked at the angle properties of a quadrilateral and we took some examples on how to use this property to find the angles in a quadrilateral. In this video, we are going to study how to find the interior and exterior angles of a polygon. So what is a polygon? A polygon is a closed plane figure with straight sides. So if you have any plane figure with straight sides that is closed, you say that you have a polygon. So for example, a quadrilateral is an example of a polygon because it's a plane figure, the sides are closed and the sides are also straight. A triangle is an example of a polygon. These are not the only polygons that we have other ones and you will see them as the video progresses. Now, the angles in a polygon are called interior angles and those outside are called exterior angles. I hope by this time you are conversant with interior and exterior angles. So if you take a polygon, the angles inside the polygon are called interior angles and those outside are called exterior angles. For a regular polygon, all the interior angles are equal and the sides are also equal in length. So if you take a regular polygon, for any regular polygon, all the interior angles are equal and the sides are also equal in length. Examples of regular polygons are squares and equilateral triangles. For squares, you see that all the sides are equal, all the four sides are equal. Then the angles, the interior angles are also equal. The same thing applies to equilateral triangles. All the sides are equal and the interior angles are also equal. When you have a polygon like that, we say that you have a regular polygon. Now, the table below shows the names of some special types of polygon. So this is the number of sides of the polygon, then here is the name of the polygon. So if you have a polygon with 3 sides, the name of the polygon is a triangle. We know that a plane figure with 3 sides is called a triangle. So any closed plane figure with 3 sides is called a triangle. 4 sides is called a quadrilateral. That's the general name for all plane figures with 4 sides. With 5 sides is called a pentagon. 6 sides is called a hexagon, and the name continues. So in this video, when you mention, let's say, an octagon, you should know that we are talking about an 8-sided plane figure. Let's say we mention a heptagon, we are talking about a 7-sided plane figure. Now, how do we find the interior angles and exterior angles of these polygons? You've seen how to find the interior angles of a triangle. You've seen how to find the interior angles of a quadrilateral. Now let's see how we can find the interior angles of a pentagon, a hexagon, a heptagon, an octagon, a nonagon, and the list continues. We are going to see how to find this. Interior angles. So interior and exterior angles of a polygon. So we are going to first consider the interior angles. If a polygon has n sides, so we are representing the number of sides of the polygon with the letter n, then the sum of all the interior angles is given by n minus 2 times 180 degrees. So if the polygon has n sides, then the sum of the interior angles in the polygon is given by n minus 2 times 180 degrees, where n is the number of sides of the polygon. I hope you understand that. So let's say we have a 3-sided polygon. It means that n is going to be 3. So if you want to find the sum of the interior angles of that polygon, just replace n with 3 and simplify this whole expression here. Let's say we have an 8-sided polygon. If you want to find the sum of the interior angles of this 8-sided polygon, just replace n with 8 and simplify the expression that you have here, and the answer that you get, that will be the sum of the interior angles of the polygon. If the polygon is a regular polygon, we know that for regular polygons, all the interior angles are equal. So if the polygon is a regular polygon, then each interior angle is given by n minus 2 times 180 divided by n. So if the polygon is a regular polygon, because we know that all the interior angles are equal, if you want to find one of them, you divide the sum of the interior angles by the number of sides of the polygon. That is why we are having n minus 2 times 180 degrees divided by n. We are going to pick some examples so you see how to use the formula that we have here. Let's move on to the exterior angle. The sum of all the exterior angles of a polygon is 360 degrees. So it doesn't matter which type of polygon. The sum of the interior angles of all, the sum of the exterior angles of all polygons is 360 degrees. So if it's a heptagon, a hexagon, a nonagon, pentagon, it doesn't matter. If you sum all the exterior angles, you are going to get 360 degrees. But if the polygon is a regular polygon, because we know that for regular polygons, the interior angles are equal, the exterior angles are also equal. Each exterior angle is equal. So if the polygon is a regular polygon, then each exterior angle is given by 360 degrees divided by n. That is the 360 degrees we have here divided by the number of sides, where n is the number of sides of the regular polygon. So the sum of the exterior angles of a polygon is 360 degrees. If the polygon is a regular polygon, then each exterior angle is given by 360 degrees divided by n, where n represents the number of sides of the regular polygon. Now let's see how we can apply these formulas to solve some questions. Let's take the first question. A regular polygon has 8 sides. So here the question is telling us that the polygon is a regular polygon. Find the exterior angle. What this means is that we should find one exterior angle, and because the exterior angles are equal, we know that it's going to be 360 degrees divided by n, where n is the number of sides. Here we have been given the n. We are also told to find the sum of the interior angles, and we are supposed to find the interior angle, that is one interior angle. So here we are finding one exterior angle, here we are finding one interior angle, and for the B we are finding the sum of the interior angles. Okay, we know that the number of sides of the polygon is 8, so it means that n is 8. The first question told us to find the interior angle of the polygon. We know that the first question told us to find the exterior angle of the polygon. We know that the exterior angle of a regular polygon is equal to 360 degrees divided by n. Remember, this is different from the sum of the exterior angle. This is the exterior angle. The exterior angle of a regular polygon is 360 degrees divided by n. We know that n is 8, so it's going to be 360 degrees divided by 8, and this is going to give us 45 degrees. So it means that each exterior angle of this regular polygon is 45 degrees. This is an 8-sided polygon, so it's called an octagon. Let's consider the B, the sum of the interior angles of the polygon. We know that the sum of the interior angles of a polygon is given by n minus 2 times 180 degrees. N is 8, so we are going to have 8 minus 2 times 180 degrees. We simplify this and we are getting 1080 degrees. So if you sum all the interior angles in the regular polygon, we are going to get 1080 degrees. The question told us again to find the interior angle of the polygon. The interior angle, it means that it's asking for one interior angle. You see here, the question told us to find the sum of the interior angles, but here we are told to find the interior angle, so it's asking for just one interior angle, and we know that that is given by n minus 2 times 180 degrees divided by n. We know n to be 8, so you place every n with 8 and you simplify, we are getting 135 degrees. So you place n with 8, then you simplify the whole thing and we are getting 135 degrees. Let's look at another question. A regular polygon has 5 sides. So this is a regular polygon with 5 sides, so it's called a pentagon. Find A, the exterior angle, B, the sum of the interior angles, and C, the interior angle. We know that the number of sides are 5, so n will give us 5. The exterior angle of a regular polygon is given by 360 degrees divided by n. Once again, this is different from the sum of the exterior angle, which is 360 degrees. This, we are supposed to find the exterior angle, which means that it's asking for one exterior angle, and because the polygon is a regular polygon, it's given by 360 degrees divided by n. So we replace n with 5 and we are getting 72 degrees. So if you have a regular pentagon, that is all sides are equal, then the exterior angle is given by 72 degrees. The sum of the interior angles of a polygon is given by n minus 2 times 180. We are supposed to find the sum of the interior angles of this polygon, which is a 5-sided figure, a pentagon. So we replace n with 5. We are getting 5 minus 2 times 180 degrees. This will give us 3 times 180 degrees, and we are getting 540 degrees. So it means that if you have a pentagon, the sum of the interior angles of the pentagon is 540 degrees. The last question told us to find the interior angles of the regular polygon. That is one interior angle, and we know that to find one interior angle is going to be n minus 2 times 180 degrees divided by n. N is 5, so you place 5, n with 5 here, so you are getting 5 minus 2 times 180 degrees divided by 5, and this, if you simplify the whole thing, we are getting 108 degrees. We are having 108 degrees for this pentagon. Thank you for watching this video on finding the interior and exterior angles of a polygon. In the next video, we are going to pick more questions on using the formulas that we learned in this video to find the interior and the exterior angles of a polygon. Bye bye. We are on the topic plane geometry. In the previous video, we learned how to find the interior and exterior angles of a polygon, and we solved some examples. In this video, we are going to solve about 3 examples on finding the interior and exterior angles of a regular polygon. So we have about 3 questions here, and we are going to pick them one after the other. So let's pick the first question. The sum of the interior angles of a regular polygon is 2160 degrees. Find the number of sides of the polygon. So let's begin with this question. The sum of the interior angles of a regular polygon is 2160 degrees, and we are being told to find the number of sides of the polygon. We know that the sum of the interior angles of a regular polygon is n-2 times 180 degrees. Now the question is telling us that there is this polygon. If you sum the interior angles, you are going to get 2160 degrees. Now we are supposed to find the number of sides of the polygon. We know from this formula tree that the sum of the interior angles of a polygon is given by n-2 times 180 degrees, where n is the number of sides. So it means that we can equate n-2 times 180 degrees to 2160 degrees. Then we can find n, and that n will give us the polygon that is giving us the sum of its interior angles to be 2160 degrees. I hope that is clear. So all the question is telling us is that there is this polygon. There is a polygon here. So let's say that all the question is telling us that there is this polygon. We don't know the number of sides of this polygon. So let's draw any polygon. Okay, so there is this polygon here. I can't draw this very well because I'm using the mouse on my computer. Okay, so there is this polygon here. Now, with this polygon, if you sum all the interior angles, you are getting 2160 degrees. We are supposed to find the number of sides of the polygon. I hope that is clear. But we also know that the sum of the interior angles of a polygon, the formula is n-2 times 180 degrees. So if we are able to equate this to the sum of the interior angles of the polygon, that has been given us to be 2160 degrees. Then we can find n, which is the number of sides. I hope that is clear. So we have this. This becomes linear equation. So we are supposed to expand this. So what we are going to do is that straight away I'm going to divide this side here by 180 degrees. Then I divide this side here too by 180 degrees. So from here, 180 degrees will cancel 180 degrees. So this side is going to be n-2, because here will cancel itself 1. It will cancel here 1. So I'm going to have n-2. 2160 degrees divided by 180 degrees will give us 12. So I make n the subject, and I'm getting the number of sides to be 14. So what it means is that the number of sides of the regular polygon is 14. So a regular polygon with 14 sides, if you sum the interior angles, you get 2160 degrees. I hope that is clear. So after you've written this, the rest is linear equation, and somebody can choose to expand the brackets, group like terms, then you simplify. Somebody can choose to divide it straight away, as I did here. Any way that you do it, you are going to get the number of sides, which is n, to be 14. Let's consider the next question. The interior angle of a regular polygon is 60 degrees. Find the number of sides of the polygon. Now look at this very well. In the previous question, we were told that the sum of the interior angles. Now here, the question is telling us that the interior angle, so this is different. This is the interior angle of a regular polygon, and the question is telling us that the interior angle of this regular polygon is 60 degrees, and we are being told to find the number of sides of the polygon. Now, we know that the interior angle of a regular polygon is given by n-2 times 180 divided by n. The interior angle of this polygon that the question has given us is 60 degrees. So we are supposed to find n. So what that means is that we equate n minus 2 times 180 degrees divided by n to 60 degrees. Then we find the value of n. I hope that is clear. So after we've written this, the rest is linear equation. We know from linear equation that to simplify this, you multiply through by the LCM, which is n. So you multiply this side by n, we multiply this side by n. So n will cancel n to give us n minus 2 times 180 degrees is equal to 60 times n. Now what I'm going to do is this. I'll divide this side by 60. I'll divide this side by 60. So 60 will cancel 60 here. So this side is going to give us n. So because I'm dividing this side by 60, so 60 will cancel 60. 60 here will cancel 60. So this side is going to give us n. 60 degrees will cancel itself 1. Cancel 180 degrees 3 times. So I'm going to have 3 times what we have in the bracket here, which is n minus 2. You open this bracket, I'm getting 3 times n minus 6 is equal to n. We group like terms, I will get 3n minus n is equal to 6. 2n is equal to 6, so n is equal to 3. Now if you have n to be 3, it means that the number of sides of this polygon is 3. A polygon with 3 sides is a triangle. And because the question told us that this is a regular polygon, then it means that this particular triangle is an equilateral triangle. We know that for equilateral triangles, the interior angle, one interior angle is 60 degrees. So you have been able to solve this question too. Let's consider the next question. Find the number of sides of a regular polygon whose exterior angle is 45 degrees each. So for this regular polygon, each exterior angle is 45 degrees, and we are supposed to find the number of sides of this regular polygon. The exterior angle of a regular polygon is given by 360 degrees divided by n. Once again, this is different from the sum of the exterior angle, which is 360 degrees. Here, this is the exterior angle of the regular polygon, and it is 360 degrees divided by n. The question told us that the exterior angle of this polygon is 45 degrees. So if you're able to equate 60 degrees to 45 degrees, we're able to equate 360 degrees divided by n to 45 degrees, then you will be able to find n. I hope that is clear. So if you write this, it now turns to a linear equation. We divide both sides by n, so n will cancel n. We are going to get 360 degrees equal to n times 45 degrees. We divide both sides by 45 degrees, so 45 will cancel 45. 360 degrees will be divided by 45 degrees, and n is giving us 8. So n is equal to 8. It means that the number of sides of this polygon is 8. An 8-sided polygon is called an octagon. An octagon. Thank you for watching this video on finding the interior and exterior angles of a regular polygon. Pick more examples and try your hands on them. In the next video, we are going to solve more examples on finding the interior and exterior angles of a polygon. Bye bye. We are on the topic plane geometry. In the previous video, we solved some questions on finding the interior and exterior angles of a regular polygon. In this video, we are going to solve about 4 questions on finding the interior and exterior angles of a regular polygon. So let's begin with the first question. You are being told to find the value of s in the following diagrams. So we have our first diagram here, and we are going to find the value of s. Now you can see that in this diagram, we have been given 5 interior angles. So we have 2s, 4s, 2s, 4s, and 3s. These are all interior angles. So if you're able to find the sum of the interior angles of this regular polygon, then we can add this to this, to this, to that, and equate it to the sum of the interior angles of this regular polygon. You know that if this were to be a quadrilateral, we will say that the sum of the interior angles of a quadrilateral is 360 degrees. So we add everything here, equate it to 360 degrees. But look at this plane figure or this polygon. The sides are 1, 2, 3, 4, 5. It's a pentagon, not a quadrilateral. So how do you find the sum of the interior angles of a pentagon? We know that the sum of the interior angles of a polygon is n minus 2 times 180 degrees, where n is the number of sides. So here the number of sides of this polygon is 5. It means that the sum of the interior angle of this polygon will be 5 minus 2 times 180 degrees. So you're going to have 3 times 180 degrees, which is 540 degrees. What this means is that if we add all the interior angles in this polygon, you are supposed to get 540 degrees. So we will say that 2s or 4s plus 2s plus 2s plus 4s plus 3s will give us 540 degrees. I hope this is clear. So we have been able to find the sum of the interior angles of this polygon. So we can now add the interior angles of the polygon and equate it to the sum, which is 540 degrees. This will give us 15s is equal to 540 degrees. You divide both sides by 15 and s is giving us 36 degrees. I hope this is clear. Let's consider the next example. So once again, we have been given this polygon to. All the angles that have been given in this question are interior angles. So what we have to do is that we find the sum of the interior angles of this polygon. Then we add the interior angles here and we equate it to the sum. This is a 6-sided polygon, so a hexagon. So we find the sum of the interior angles of a hexagon. We know that the number of sides is 6, as I've said, and the sum of the interior angles of a polygon is given by n minus 2 times 180 degrees. So this is going to give us 6 minus 2 times 180 degrees, which is 720 degrees. So it means that the sum of the interior angles of this polygon is 720 degrees. Because the sum of the interior angles of this polygon is 720 degrees, we can say that s plus 2s plus 2s plus s plus 2s plus 2s is 720 degrees. Okay, so we add everything here. We are getting 10s, and that will give us 720 degrees. We divide both sides by 10, and s is giving us 72 degrees. I hope that's clear. So we find, when the question is given to you like this, all you need to do is to find the sum of the interior angles of the polygon that has been given to you. Here we are given a 6-sided polygon. So you find the sum of the interior angle of this polygon. Then you add all the interior angles and you equate it to that value. Then you find for the letter or the variable in the question. Let's move on to the next one. In this diagram, you see that unlike the previous diagrams where we were given interior angles, in this diagram we have been given exterior angles. So here we have the exterior angle here to be 5s, we have the exterior angle here to be 4s, the exterior angle here is 8s, and the exterior angle here is 3s, and we are finding the value of s. We know that the sum of the exterior angles of a polygon is 360 degrees. So the sum of all the exterior angles of a polygon is 360 degrees. So if we add this exterior angle to this exterior angle to this exterior angle to this exterior angle, we should get 360 degrees. So this means that 5s plus 4s plus 8s plus 3s will give us 360 degrees. We add everything here, we are getting 20x is equal to 360 degrees. From linear equations, we know that we divide both sides by 20 and x is giving us 18 degrees. So you see in this question too, we are given the exterior angles, but because we know that the sum of all the exterior angles is 360 degrees, we will add all the exterior angles and equate it to 360 degrees, then find the value of the variable or the letter in the question. Let's look at the last question. So we have been given this diagram too. We have some interior angles and some exterior angles. Let's see how to go about this. Now, we have been given the exterior angle here. We have been given the exterior angle here. Here we are given the interior angle. We don't have the exterior angle. If you come here, you have been given the exterior angle. We have the exterior angle. Here we have the interior angle, but we don't have the exterior angle. Now you can see from here that we have two interior angles and we have about 1, 2, 3, 4 exterior angles. So it's easier using the exterior angle because that is what we have, 4 of them. For the interior angle, we just have 2 of them. So if we want to find the interior angles, it means that we have to find about 4 interior angles. So we find 1, 2, 3, 4. But if you want the exterior angle, we are just going to find 2 since we already have 4. So it is easier finding 2 than 4. So let's work with finding 2, which is the exterior angle. So here we are going to use the property that the exterior angle of a regular polygon sum up to 360 degrees. We know that there's all the exterior angles of a polygon, the exterior angles of a polygon sum up to 360 degrees. We know that all the exterior angles of this polygon is going to give us 360 degrees. When you come here, we know the exterior angle. When we come here, we know the exterior angle. The question has given it to us. Here we know. We also know it for this side. But we don't know it for this side and this side. So what we are going to do is that I'm going to assume that the exterior angle here is A. Then I will assume that the exterior angle here is B. We are going to find this A and B so that we'll be able to find S. So with this, I can say that because the sum of all the exterior angles of a polygon is equal to 360 degrees, I can say that 40 degrees plus 2S. So 40 degrees is the exterior angle here, plus 2S, which is the exterior angle here, plus A, which is the exterior angle here, plus 3S, which is the exterior angle here, plus S, which is the exterior angle here, plus B, which is the exterior angle here, will give us 360 degrees. Now we are supposed to find S, but because we have A and B, that is not going to be possible. So what we have to do is that we now find A and find B. If we have A and B, we can now find S. Now how do we find A? Looking at 130 degrees and A, we can say that 130 degrees and A are angles on a straight line. What do we know about angles on a straight line? They add up to 180 degrees. So we can say that angles on a straight line add up to 180 degrees. So A plus 130 degrees will give us 180 degrees. We simplify and A is giving us 50 degrees. So we have found A. Let's move on to B. When you come here, looking at B and 135 degrees, we can say that B and 135 degrees are also angles on a straight line. We know that angles on a straight line add up to 180 degrees. So B plus 135 degrees will give us 180 degrees. Now, B is equal to 180 degrees minus 135 degrees, and B is giving us 45 degrees. So you see, we found A, we found B, so we can now find S. How? We know that the sum of all the exterior angles of a regular polygon is 360 degrees. So 40 plus 2x plus A plus 3x plus x plus B will give us 360 degrees. We now know A, we now know B. So we replace A with the value of A, which is 50. We replace B with the value of B, which is 45. So we are going to have 40 degrees plus 2x plus 50 degrees. So the 50 here is degrees. Don't forget. So you have the 50 degrees here. So 50 degrees. Okay, I can't write this very well because I'm using the pointer on my computer. Okay, so we have 50 degrees and 40 degrees. So you're going to have 40 degrees plus 2x plus A, which is 50 degrees, plus 3x plus x plus B, which is 45 degrees, is equal to 360 degrees. So 40 degrees plus 50 degrees plus 45 degrees will give us 135 degrees. 2x plus x is 5x plus x is 6x. So we have 6x plus 135 degrees is equal to 360 degrees. 6x will give us 360 degrees minus 135 degrees. So 6x is equal to 225 degrees. You divide both sides by 6 and x is giving us 37.5 degrees. So you see that using the property of exterior angles and angles on a straight line, we have been able to find the value of this. Now try using the property of interior angles. So for interior angles, what you are going to do is that you are going to find the interior angle here. You already know this side to be 40, so you can find the interior angle here, which will be 180 minus 40. Try finding the interior angle here, find the interior angle here, find the interior angle here. Now With this and this side, we can find the interior angle here. With S and this side, we can find the interior angle here. With 2S and here, we can find the interior angle. With 40 and this side, we can find the interior angle here. After you finish with that, you see that this is a 5-sided plane figure. So 1, 2, 3, 4, 5. So it's a pentagon. We already know that the sum of the interior angles of a pentagon is 540 degrees. So you equate all the interior angles to 540 degrees, and you do that, you'll be able to find S. But you will see that that will be a long process. This is relatively shorter, so it's always easier to pick the method that will give you your answer very, very quickly, because in an examination you'll be dealing with time. Thank you for watching this video and all the videos on finding the interior and exterior angles of regular polygons. Pick more examples and try your hands on them using the principles that we've studied in the videos. If you have any problems, interact with me on my social media handles and I'll help you. In the next video, we are going to study the properties of angles in a circle. So you've studied the properties of angles in a triangle, in a quadrilateral, and in all polygons. Now we are going to study the properties of angles in a circle, and we will see how to use these properties to solve questions. Bye bye. We are still on the topic plane geometry. In the previous video, we considered how to find the interior and exterior angles of polygons. In this video, we are going to study the properties of angles in a circle. To help us understand the properties of angles in a circle, we are first going to consider the parts of a circle. So the first part of a circle we are considering is what we refer to as the circumference. I know you know these things from GHS, so we are going to go through it very quickly. The circular part of the circle is what is called the circumference. So if you have this circle here, the circular part, the distance around the circle, is what is referred to as the circumference. The next part of the circle we want to consider is an arc. An arc is a part of the circumference. So if you take a part of the circumference, what you have is an arc. So let's say that we have these 2 points, points A and points B on the circumference. So we have point A here. Sorry, I'm making point A here. Then we have point B here. Okay, so we have point A and point B on this circle. So you see, A and B is just a part of the bigger circle. So that part is what we refer to as an arc. So here we have the major arc and the minor arc. The minor arc is this smaller arc here from A through this path to this side B. The major arc is this bigger part from A through this path to this side here, which is B. So if you take a part of the circumference, we say that you have an arc. The next one that we are going to consider is what we refer to as the radius. The radius. A radius is a line. The radius of a circle is a line drawn from the center of the circle to any part on the circumference. So the line drawn from the center of the circle to any part on the circumference is referred to as the radius of the circle. So let's say that with this circle, we have this point here being the center of the circle, and we will call that point O. If you draw a line from point O to any point on the circumference, that line is referred to as the radius of the circle. So in the same way, if you draw a line from point O to this side, this one is also referred to as the radius of the circle. Remember, the radius of the circle is always equal. So what this means is that from O to A is equal to from O to B. This is a very, very important property. The radius of the circle, no matter the direction it takes, is always equal. So from O to A is equal to from O to B. Now the plural of radius is radii. So we have 1 radius and 2 radii. Let's move on to the next part of the circle we want to consider, which is the chord or a chord. A chord is a straight line joining 2 points on the circumference. A straight line joining 2 points on the circumference. So let's say that we have this circle here, and we have these 2 points, points P and points Q. So we have point P and point Q. If you draw a straight line joining point P to point Q, the straight line is referred to as a chord. So a straight line joining 2 points on the circumference is referred to as a chord. The next part of the circle we want to consider is the diameter. The diameter is the chord passing through the center of the circle. We know that a chord joins 2 points on the circumference. So if you draw a chord through the center of the circle, that chord is referred to as the diameter. So in effect, the diameter is a line passing through the center of the circle that touches both ends of the circumference. So you can see that this line here, line CD, passes through the center of the circle. We are calling the center O, and it touches this point here at the circumference at this point, and it touches the circumference at this point. So this line called line CD is referred to as the diameter. It is a chord because it touches 2 points on the circumference, but because it passes through the middle, it is given the name the diameter. I hope this is clear. Okay, so let's move on to the next part of the circumference of the next part of the circle we want to consider. A segment. A segment is an area of a circle bounded by a chord and an arc. An area of a circle bounded by a chord and an arc. We know a chord, we know an arc. So the area of a circle bounded by a chord and an arc is referred to as a segment. Let's illustrate this on a circle. So let's say we have this circle here. Then we have this chord here, chord MN. So this line here is referred to as the chord. With this same point MN, we can say that we have the arc MN. Now you see that with chord MN and arc MN, we have the area, an area of a circle bounded by this chord here and an arc here. So the area of this circle, this area, I'm going to highlight there for you to see. This is the area I'm talking about. The area of the circle here, this area here, you see that with this area is bounded by a chord and an arc. This area is what we refer to as a segment. I hope that is clear. In the same way, when you come to this part here, this area, okay, so I'm going to pick the highlighter and highlight the place I'm talking about. So if you come to this area here, this area, oh sorry, I have to clean it. I'm going to erase it. So if you come to this area here, this whole area, this bigger portion, okay, I hope you get the picture. So if you come to this area too, this whole area, you see that it's also bounded by a chord and a bigger arc. So that is also a segment. So in this diagram here, we have 2 segments. We have this one here, then this one here. Because this one is smaller, it's referred to as the minor segment, and because this is bigger, it's referred to as the major segment. So the segment of a circle, the segment is the area of a circle bounded by an arc and a chord. So we have a chord here, we have the arc here. So this is the minor segment, and when you come here, we have the chord here and we have the bigger arc here. So this is referred to as the major segment. The next part of the circle we want to consider is the sector. A sector. The sector of a circle is the area of the circle bounded by 2 radii and an arc. So you see, a segment is bounded by a chord and an arc. A sector is bounded by 2 radii and an arc. So let's say we have this circle here. Now we have the center of the circle, I'm calling it O. We have this radius here, and we have this radius here. I'm calling this point here point P and point Q. Now you can see that with this area, this particular area here is bounded by this radius, and this arc here. So this area is referred to as a sector, an area bounded by two radii. So we have the radius PO and radius QO, and we have the arc PQ. So an area bounded by two radii and an arc is what we refer to as a sector. When we come to this bigger side here, too, you see that it's also bounded by this radius, and the bigger arc. So this area is also a sector. Because this part is small, we refer to this part as the minor sector, and because this is the biggest of the two, we refer to this side here as the major sector. I hope that is clear. Now, there is a very, very important property about this minor sector here that you have to know. Let's say that we join point P to point Q with a straight line. So we are going to have a chord, the chord PQ. We draw the chord PQ. Now you can see that as soon as you draw the chord PQ, we have formed a triangle POQ. PO is a radius, PO is also a radius. So if we are referring to PO as the radius and we are using the letter R to represent it, QO is also R, because you said that the radius of the circle is always equal no matter the direction it takes. What this means is that this line PO is equal to line QO. So this side here is equal to this side. Now, as soon as you see these two bars, what comes to your mind? We have POQ as a triangle. This side here is equal to this side. So it means that triangle POQ is an isosceles triangle. So if the angle formed here is X, the angle formed here is also X. This is a very, very important property of the minor sector that we have here. We are going to use this property as we move on in our studies on angles in a triangle. Thank you for watching this video on the parts of a circle. In the next video, we are going to use these parts of the circle that you've studied to delve into studying the angles, properties of angles in a triangle. Properties of angles in a circle. So in the next video, we are going to use the parts of the study of the circles that we've studied in this video to study more about the properties of angles in a circle. Bye bye. We are on the topic plane geometry. In the previous video, we looked at the parts of a circle. In this video, we are going to study the properties of angles in a circle. So let's begin that. Angles in a circle. So the properties of angles in a circle is also referred to as the circle theorem. So we are going to study about 10 theorems or 10 properties of angles in a circle. The first property is that the angles a chord or an arc subtends at the circumference in the same segment of a circle are equal. What does this mean? Let's say that we have this circle here. Then we have this chord AB. Now you see this is chord AB. It can also be arc AB. For simplicity's sake, I'm going to refer to it as chord AB. So as soon as we have this chord, we have divided the circle into a minor segment and a major segment. Now this property says that the angle a chord or an arc, so here I'm going to use the chord, the angle a chord subtends at the circumference in the same segment are equal. What this means is that if we draw a line from A to this point of the circumference, now we draw a line from B to this point of the circumference, you see that this chord AB has created an angle here. Now if this same chord AB, we draw a line we are going to call this point here point C. Now with this same chord called AB, if you draw a line from A to another point on the circumference, like what you have here, then we draw another chord, you draw another line from B to a point on the circumference here as we have here, and we call this point here point D. Now you can see that chord AB has created an angle here, and the same chord AB has also created an angle here. What this property says is that because it's the same chord AB creating this angle and this angle in this segment, the angles are equal. What this means is that angle ACB, which is this side, and angle ADB, so ADB, which is this angle here, are equal. So if the angle formed here is S, the angle formed here will also be S. So all that this property says is that if you have a chord or an arc subtending an angle at the circumference in the same segment of a circle, the angles formed will be equal. So if this chord here forms this angle at this circumference, form the angle at this place, because they are in the same segment, the angles are equal. Let's move on to the second property. The second property says that the angle a chord or an arc subtends at the center of a circle is twice the angle it subtends at the circumference. What does this also mean? So we have this circle here. Now this circle has a center called O. So here is the center of the circle. Let's say that we have this chord here, chord AB. Once again, it can be either the chord or the arc. I'm using the chord to make it simpler. So we have this chord here, chord AB. Now, if you draw a line from A to the center, we know that this is the radius. We draw another line from B to the center. This is also the radius. So you see that from A to B, from A to O, and from B to O, we have created an angle here. There has been an angle created at the center by the chord AB. What the property says is that with this angle here, if this same chord, we draw a line from A to a point on the circumference here, we draw a line from B to a point on the circumference here, and we call that place point C, you see that another angle will be created there. Now, chord AB is forming this angle at the center, and the same chord AB is forming this angle at the circumference. The property says that the angle a chord or an arc subtends at the center is twice the angle it subtends at the circumference. So the angle subtended at the center, that is the angle created at the center, is 2 times the angle created at the circumference. I hope that is clear. So all that this means is that angle AOB, so the angle from here, angle AOB, so AOB, this bigger angle here, is equal to 2 times angle ACB. So if the angle formed here is S, the angle formed here will be 2 times S, which is 2S. Let's move on to the third property. The sum of the angles a chord or an arc subtends at the circumference of opposite segments of a circle is equal. So here you have to cancel this off. So I'm going to cancel it. Okay. Oh, sorry. So I cancelled that. So the sum of the angles a chord or an arc subtends at the circumference of opposite segment of a circle is equal. Is equal to 180 degrees. Sorry. The sum of the angles a chord or an arc subtends at the circumference of opposite segments of a circle is equal to 180 degrees. What does this mean? Let's say that we have this circle here. Now we have a chord called AB or arc AB. This chord here, if you draw a line from A to a point on the circumference here, you draw a line from B to a point of the circumference here, we know that an angle will be created here by the chord. So we say that the chord has subtended an angle at the circumference here. Now you can see that as soon as you bring the chord, we have divided the circle into a major segment and a minor segment. So here is one segment and here is another segment. In the previous video, we explained what a segment is. So we form this angle here in this segment at the circumference. Now if this same chord here forms an angle here, you see that the angle that will be formed if you draw a line from A to this point and draw a line from B to this point, another angle will be created. But this angle is in a different segment. This angle created here is in the minor segment. The one created here is in the major segment. What the property is telling us that the sum of the angles created at the segments, if you add them, you are going to get 180 degrees. The angles created at the different segments at the circumference, if you add them, you are going to get 180 degrees. So what this means is that if the angle created here is called S and the angle created here is called Y, if you add S and Y, you must get 180 degrees. So if this chord here is creating an angle at the circumference in this segment called S, and the same chord is creating an angle at the circumference in another segment, and we are calling that angle Y, S plus Y will give us 180 degrees. Let's move on to the fourth property. The angle the diameter of a circle subtends at the circumference is 90 degrees. So this is S. So the angle the diameter subtends at the circle is 90 degrees, not in 90 degrees. It's 90 degrees. So the angle the diameter of a circle subtends at the circumference is 90 degrees. What this means is that if you have this circle here with the center O, we know that the diameter is the chord passing through the center. So we call this diameter AB. So if this diameter, we draw a line from here to the circumference, then a line from here to join that particular point, I'm calling that point D. We are saying that the angle that this diameter will create at the circumference is 90 degrees. So what it means is that the angle formed here is a right angle or a 90 degrees angle. So in the same way, if you draw a line from A to this point here, and you draw a line from B to this point here, the angle created there, let's say we call that point C, the angle created there be 90 degrees. So we can say that angle ACB is 90 degrees and angle ADB is also 90 degrees. Let's move on to the next property. Equal chords or arcs subtend the same angles at the circumference of a circle. What does this property also mean? Let's say we have this circle here. We have this arc, this chord here called AB. We have another chord in the circle called PQ. Now, chord AB is equal to chord PQ. So I've drawn one line here, showing that AB is equal to PQ. Because they are the same or because they are equal, the angle that AB will form at the circumference here, I'm calling this point of the circumference C, that angle will be the same as the angle that PQ will also form at the circumference. So what this means is that angle ACB is equal to angle PRQ. So if the angle formed here is X, the angle formed here will also be S, because equal chords or arc subtend the same angle at the circumference of a circle. Let's move on to the next property. Equal chords or arc subtend the same angle at the center of a circle. So once again, let's say we have this circle with the center O. Now we have a chord called AB. We have another chord called PQ. Chord AB is equal to chord PQ. So this chord here, if you draw a line from here to the center, you draw a line from B to the center, we know that this angle will be created. We draw a line from P to the center, we draw a line from Q to the center, we know that another angle will be created. This property says that because AB is equal to PQ, the angles that they will create at the center of the circle will be the same. So what this means is that angle AOB is equal to angle POQ. It means that if the angle created here is S, the angle created here will also be S. I hope that is clear. Let's move on to the next property. The angle between a chord and a tangent at the end of the chord is equal to the angle subtended by the chord in the alternate segment. I'm going to use the diagram to explain this property to you. Let's say we have this circle. We know a chord. What we don't know in this statement is the tangent. So what is a tangent? This term. What is a tangent? You are going to hear it a lot. So I'm going to underline it and explain to you. That term, a tangent, what is it? A tangent is a line drawn to touch a part of a circle or a point on the circle. So if you draw a line that touches a point on the circle, that line is referred to as a tangent. For example, this line. You can see that this line is touching the circle at this point. So we see that this line here is a tangent. I'm going to call this tangent AC, or this line AC. Now let's go on to the property. The angle between a chord and a tangent. So let's say that we have this line AC. Now we also have a chord at the point of contact, or at the point where the tangent touches the circle. There is a chord. So we are going to call this chord also chord AD. We are saying that the angle between a chord and a tangent, you see that when the chord and the tangent meet, an angle will be created. This angle here, the angle between the chord and the tangent at the end of the chord, so this is the end of the chord at this place, is equal to the angle subtended by the chord in the alternate segment. Now you see that this chord AD, let's say that we draw a line from A to a point on the circumference, and we draw a line from D to a point on the circumference. There's going to be an angle created here. An angle created here. What this property is telling us that, so we are going to call this point here point B. What this property is telling us that if you have this, then angle ADB, which is angle ABD, that is the angle created by the chord in the circle here, is equal to the angle created between the chord and the tangent, that is angle ACD. So if the angle created between the chord and the tangent is S, then the angle created by the chord in the circle is S. I hope that is clear. So the chord and the tangent will meet, create an angle S. The angle created by the chord in the circle will also be S. I hope that is clear. That is why the point says that it's equal to the angle subtended by the chord in the alternate segment. You see, as soon as you draw the chord, it divides it into the minor segment and the major segment. So the angle created in this minor segment here is equal to the angle created by the chord in the major segment or the alternate segment. Let's look at the next property. The opposite angles of a cyclic quadrilateral add up to 180 degrees. We know that a quadrilateral is a four-sided plane figure. So if you have a circle, then you have a quadrilateral that fits into the circle like we have here. So we are going to call this quadrilateral ABCD. Now because the quadrilateral fits into the circle, we call this quadrilateral ABCD a cyclic quadrilateral. If you have a cyclic quadrilateral, the property says that opposite angles of a cyclic quadrilateral add up to 180 degrees. What this means is that if the angle created at the point D is S and the angle created at the point B is M, because S and Y are opposite angles in a cyclic quadrilateral, S plus Y is equal to 180 degrees. In that same way, if the angle created at A is N and the angle created at C is Y, because they are opposite angles in a cyclic quadrilateral, N plus Y is equal to 180 degrees. Let's move on to the ninth property. A tangent to a circle makes an angle of 90 degrees to the radius at the point of contact. We now understand a tangent. So what is the meaning of this property? This property means that if you have a circle, let's say with this, we have this circle with the center O here. If we draw a tangent to the circle here, so we are calling this tangent AB. Now the tangent to the circle will make an angle of 90 degrees to the radius. So if you have the tangent, then you draw the radius, that is a line from the center to a point on the circumference. This time the radius will touch the circle at the point where the tangent is also touching the circle. When that happens, we say that the angle created the angle OAB, that is the angle created between the radius and the tangent at the point of contact, is 90 degrees. So the angle created here will be 90 degrees. Let's look at the 10th and final property. The length of two tangents from a point outside the circle are equal. What does this mean? Let's say that we have this circle here. Now with this circle, we have a point outside the circle. I'm calling that point C. If we draw a line from C to touch the circle, we know that this is a tangent. I'm calling the point of contact point B. Then from this same point C, we draw another line to touch the circle. I'm calling that point of contact here point A. Because the tangent is from a common point, we say that line BC is equal to line AC. So the length of BC is equal to the length of AC. Thank you for watching this video about the properties of angles in a circle. See you in the next video where we will use the properties that we've learned in this video to solve some questions. Bye bye. We are still on the topic plane geometry. In the previous video, we studied the properties of angles in a circle, or the circle theorem. In this video, we are going to use the properties that we studied to solve some questions. So let's begin by taking the first question. The question says that we should find the value of S in the diagram below. So you have been given this diagram and we have to find the value of S. As I usually do it, I'm going to push the diagram to this side so that we can write our solution here. Okay, so whenever you are being given a question like this, what you have to do is to study the diagram very well, then record the properties that you've learned, and you look at which property will help you to solve the question, then you use it in the solution. So looking at this diagram, we can see that we have this arc here, arc AB. To make it simpler, I'm going to introduce this short dashes here so that it completes it as the chord AB. So it can be either arc AB or chord AB, any one of them. Now you can see that this chord here is creating this angle at the center. The same chord is creating this angle at the circumference. So chord AB or arc AB is creating an angle at the center called S. The same chord AB or arc AB is creating an angle at the circumference. Remember that when we were learning the properties in the previous video, we had a property that talks about angles created at the center and at the circumference. What is that property? The property says that the angles a chord or an arc subtends at the center of a circle is twice the angle it subtends at the circumference. What this means is that the value of S here is 2 times the value of the angle created as the circumference, which is 40. So S is equal to 2 times 40, and S will give us 80 degrees. So you see, if you quote this property and we understand how to use the property, we can use it to simply solve the question. Let's pick the next example. We are supposed to find the value of the letters or letter in the following diagrams, and we have been given this diagram here. We have the letters A, B, and C, and we are going to find their values. So let's look at it. You see that in this diagram, because this line ST is passing through the center of the circle, which is O, we can say that line ST is the diameter. So here O is the center. Remember that if the question does not tell you that a certain line is the diameter, don't assume it to be the diameter. Here the question told us that O is the line ST is passing through O. So it means that ST is the diameter and O is the center of the circle. So if ST passes through O, then ST is the diameter. Okay, so we have the line ST as the diameter here. We can also see that PQ, or the line PQ, is a tangent to the circle at the point T. So PQ is a tangent to the circle at the point T. In the previous video, we explained what a tangent is. So if PQ is a tangent to the circle at the point T, the line TR, which is a chord, so TR is a chord, there's an angle created between TR and PQ, which is the tangent. We know a property about angles created between a chord and a tangent at the end of the chord, so we can use that to find. We also know that the angles that a diameter will create at the circumference of a circle is equal to 90 degrees, so we can also use that. So we have a lot of properties here that we can use. The first one we are going to call upon is the angles the diameter of a circle subtend at the circumference is 90 degrees. So if this is the diameter, it is creating this angle, the diameter here, so we draw a line from S to this point, we draw a line from T to this point, and it's creating an angle of B. We know that the angles that the diameter will create at the circumference is 90 degrees. So what that means is that B is 90 degrees. Let's move, so we found B. Let's look at another property that will help us to find another letter or variable. We know that the angle between a chord and a tangent at the end of the chord is equal to the angle in the alternate segment. So if you take here, if you take the line PT and if you take the tangent PQ and the chord TR, the angle created between them is 50 degrees. From the previous video, we said that the angle created here will be the same as the angle created by the chord TR in the circle, which is C. So the angle created by the chord TR in the circle is C. So what that means is that C is also equal to 50 degrees. So we have been able to find C, we have been able to find B. We are now left with finding A. Okay. Now we know that the interior angles of a triangle sum up to 180 degrees. So if we add C to B to A, you are going to get 180 degrees. Now we know C to be, we know that C is 50 degrees. So if C is 50 degrees and B is 90 degrees, A plus 90 plus 50 will give us 180 degrees. We simplify this and we are getting A to be 40 degrees. So you see, we've used the properties that we know to be able to solve this question. Let's pick the next one. The diagram looks a bit clumsy, so we are going to take it one after the other and solve it. It's not difficult at all. So let's study the diagram very well. Here also, O is the center of the circle. For simplicity's sake, in this video, whenever we see a point here with O in the center of the circle, it means that that is the center of the circle, and any line that passes through the center there is the diameter. In an examination, the question will tell you whether it is the diameter or not. So here we have point O and the line PN is passing through O. So what that means is that the line PN is the diameter. We know that the angles created at the circumference by the diameter will be, they say, will be 90 degrees. So the angle that is created by this diameter at the circumference will be 90 degrees. So we can use that to find one of the variables. Now let's look at it very well. From this diagram, you see that QM or MQ, the line MQ or the chord MQ is equal to the chord MN, because we have this bar here and this bar here showing that MQ is equal to MN. Let's recall some properties that will help us. We know that the angles a chord or an arc subtend at the circumference in the same segment of a circle are equal. What this means is that if you have, looking at this side, MN subtends this angle 40 degrees at the circumference here at this point P, the same MN also subtends this angle at this point here, point Q, and that angle is D. We know that if the chord is equal, the angle they are going to subtend at the circumference in the same segment will also be equal. So if MN is forming 40 degrees here, and the same MN is forming D here, then it means that D is equal to 40 degrees. I hope that is clear. Now let's move on. We also know that the angles the diameter of a circle subtends or creates at the circumference is 90 degrees. Sorry, this is S. So it's 90 degrees. Okay. So the angles the diameter of a circle subtends or creates at the circumference is 90 degrees. So we know that the diameter PN is forming an angle of D at the circumference. So from N to this point, from P to this point, the angle formed there is B. Sorry, the angle formed there is B. We know that the angles a diameter creates at the circumference is 90 degrees. So it means that B is also 90 degrees. So we have found D, we have found B. Let's look for a way to find C and A. Now, look at this very well. We can see that MQ is equal to MN. What that means is that from here to here is the same, from here to here is the same. So joining N to Q, we can have triangle MQN. And because two sides of the triangle are the same, triangle NMQ is an isosceles triangle. What do we know about isosceles triangles? The angles formed at the basis of the lines that are equal are also equal. So the angles formed at the basis of the line that are equal are equal. So it means that the angle formed at the base here, which is D, will be the same as the angle formed at the base here, which is C. So D is equal to C. We already know D to be 40 degrees, so it means that C is also 40 degrees. So we have been able to find D, we have been able to find C, we have been able to find B. How do we find A? Okay. We know that the interior angles of a triangle sum up to 180 degrees. What are the interior angles of the triangle MNMQ? D, C, and when you come here, this whole angle here, which is A plus B. So from this property, we know that D plus A plus B plus C will be the interior angles of NMQ, and they must add up to 180 degrees. So D is 40 degrees, A is what we are looking for, B is 90 degrees, and C is 40 degrees. You add everything here, we are getting 170 degrees. So angle A will give us 10 degrees. So whenever the question is given to you, sometimes you have to apply more than one property. So you study the diagram very well, then you apply the property that will help you to solve the question. Now let's consider this, and we are being told to find S and Y. So let's look at this one also very well. As I said, whenever you see a point with the letter O there, it means that that is the center. So any line passing through that is the diameter. So how can we find O here? You can see from here that DC is a chord and it's creating an angle at the center of the circle. So from D to O, from C to O, there's an angle created at the center. The same chord DC, from D to B and from C to B, an angle is also created at the circumference. We know a relationship that exists between chords creating angles at the center and chords creating angle at the circumference. What is that relationship? The angle a chord or an arc subtends at the center of a circle is twice the angle it subtends at the circumference. What that means is that 80 degrees here is equal to 2 times the angle that will be formed here, which is S. So we simplify this, we divide both sides by 2, and S will give us 40 degrees. So we've used this property to find S. Now let's look at a way to find Y. Let's study the diagram very well. We can see that OC and DC. OC is a diameter, OC is a radius, and DC is also a radius. What that means is that the line DC This is what I want to mean. OC is a radius, OC is a radius, and OD is also a radius. So from this we can deduce that the line OD is equal to the line OC. I hope that is clear, because the radius of a circle is always equal. So from O to D, which is a radius, will also be equal to from O to C, which is also a radius. Now you can see that DOC, the lines have been joined to form a triangle there. So we can see that the triangle DOC is an isosceles triangle. Look at it very well. So triangle ODC or DOC is an isosceles triangle. And if it's an isosceles triangle, it means that if the angle formed here is Y, the angle formed here, which is ODC, the angle formed here will also be Y, because it's an isosceles triangle. Remember when I was explaining sectors in the video on part of circles, I explained this property about sectors. Now, if we have here to be Y, here to be Y, and here to be 80 degrees, we can proceed and find Y. We know that the interior angles of a triangle sum up to 180 degrees. So 80 degrees plus Y will give us 180 degrees. 80 degrees plus 2Y will give us 180 degrees. You simplify this, 2Y will give us 100 degrees and Y will give us 50 degrees. This is one way of solving the question. You can think of another way by applying some of the other properties that we've learned. So study the diagram very well, record the properties that you've learned, and pick the ones that will help you to solve the question. Thank you for watching this video. See you in the next video, where we will take more questions on finding angles in a circle. Bye bye. We are still on the topic plane geometry. In the previous video, we saw some examples on finding angles in a circle. In this video, we are going to consider some more examples. So let's begin with the first one. Find the value of the letters or the letter in the following diagram. So here we have about 3 letters here. That is the letter S, the letter N, and the letter Y. So we are supposed to find the value of these letters. Now, let's consider the diagram very carefully. Looking at this diagram here, I can see a cyclic quadrilateral. We have T, P, R, Q as a cyclic quadrilateral. So T, P, R, Q is a cyclic quadrilateral. What do we know about cyclic quadrilaterals? We know that the opposite angles in a cyclic quadrilateral are equal. So straight away we can add S to 100. Sorry, the opposite angles in a cyclic quadrilateral add up to 180 degrees. They are not equal. They add up to 180 degrees. So we can add S to 100 degrees and equate it to 120 degrees so that we'll be able to find S. So looking at the diagram straight away, we have been able to think of a property that will help us to find one of the variables. Now let's begin to solve the question. The opposite angles of a cyclic quadrilateral add up to 180 degrees. So what this means is that S plus 100 degrees will give us 180 degrees. So S is equal to 80 degrees. So we have been able to find S. Now this is gone. Let's deal with Y, N, and Y. Now look at this very well. Look at P and Q. Let's say that we draw a line to join P and Q. See, you are going to have the chord PQ. What do you know? You see that chord PQ is forming this angle at the center, called angle N, because from P to O and from Q to O. So PQ is creating this angle at the center. It is subtending this angle at the center called angle N. The same PQ is also creating this angle at the circumference, which is S. We know a property about chords creating angle at the center and at the circumference. That property says that the angle a chord or an arc subtends at the center of the circle is twice the angle it subtends at the circumference. What this means is that the angle created at the center here is 2 times the angle created at the circumference. We know that the angle created at the circumference is S. we already know the value of s, so n will be 2 times s, which is 80 degrees, so n will be 160 degrees. So now we have found s, we have found n, we are left with y. Now let's continue. We can see that P O Q R is also a quadrilateral. P O Q R is a quadrilateral. We know this angle here to be 40 degrees, so this is what I mean. We know the angle created here to be 40 degrees. We know the angle created here to be 100 degrees. We know the angle created here, we have found it is 160 degrees. What we don't know is y. But we know that if you add the interior angles of a quadrilateral, you are going to get 180, you are going to get 360 degrees, right? So interior angles of a quadrilateral is the sum of the interior angles of a quadrilateral is 360 degrees. So we can say that 40 degrees plus 100 degrees plus n plus y will give us 360 degrees. We know the value of n, so we are going to have 40 degrees plus 100 degrees plus 160 degrees plus y will give us 360 degrees. We simplify this and y is giving us 60 degrees. So we have been able to find s, we have been able to find n, and we have been able to find y. Once again, this is one way of doing it. Try using another way and see if you'll be able to find the value of x, n, and y. So try any of the other properties and see if it can work on this diagram so that you'll be able to find the value of s, n, and y. Let's consider the next diagram. So with this diagram here, we are supposed to find the value of y. We are finding the value of y here. Now, O is the center, but you can see that the line AC is not passing through O. It means that AC is not the diameter. In the same way, line BD is also not passing through the center, so it means that line BD is not the diameter. So we can't use the properties of diameter here. Now looking at this, there is an arrow in line AB, meaning that line AB and line DC, which also has an arrow, are parallel lines. So line AB is parallel to line DC. Now as soon as we have parallel lines, remember that we can use alternate angles, we can use corresponding angles, we can use co-interior angles. Anyone that will help us to solve the question, we can use it. We can only use those properties when we have parallel lines. So when you have parallel lines, you can employ those properties and add it to the other properties that you know, so that you'll be able to use it to solve the question. Now let's begin. How do we find y? We have an angle here which is given 40 degrees, so it is always easier to start from where you have been given an angle, then you work towards where you don't have the angle. Let's look at this diagram very well. If I draw a chord to join AD, you can see that chord AD, it creates an angle of 40 degrees at B. The same chord AD is creating an angle here. We know that angles created or subtended at the circumference by the same chord in the same segment are equal. So if AD is creating an angle of 40 degrees at B here, then it means that the angle that AD is creating at C will also be 40 degrees. So what this means is that angle ACD, that is the angle created here, is also 40 degrees. So we have used this property to find here to be 40 degrees. Now let's look at this also very well. We know that alternate angles are equal. Now looking at this diagram very well, we can see that 40 degrees and the angle created here, which is angle BDC, so angle BDC, the angle created here, are alternate angles. Look at it very well. So the line goes this way, there's the parallel line, this is the transversal, then this is the parallel line. So the angle created here and 40 degrees are alternate angles. So what it means is that this angle here is also 40 degrees. So we have here to be 40 degrees, we have here to be 40 degrees, we have here to be y. We know that interior angles of a triangle add up to 180 degrees. So what we can say is that 40 degrees plus 40 degrees plus y will give us 180 degrees. Since DOC or D, then this point C, we don't know the name of this point, it was not given to us. O is the center. So D, then the point here, and C is forming a triangle. We can say that 40 degrees plus 40 degrees plus y will give us 180 degrees. When we simplify this, y is giving us 100 degrees. So y is giving us 100 degrees. So you see here, we had power lines, so we're able to add alternate angles to the other properties that we've learned, and use that to find the value of y. Let's move on to the next question here. We are supposed to find the value of s and y. Now, consider the diagram very well. I can see that ABCD is a cyclic quadrilateral. That is a quadrilateral that fits into a circle. What do we know about cyclic quadrilaterals? We know that opposite angles of a cyclic quadrilateral add up to 180 degrees. We know that s and 80 degrees are opposite. So s plus 80 degrees will give us 180 degrees. You simplify, s is giving you 100 degrees. We also know that y and 85 degrees are also opposite angles in the cyclic quadrilateral. So y plus 85 degrees, sorry, this is in degrees. The 85 is in degrees, so I'm going to try and write it there. Okay, sorry, I'm using the pointer on my computer, so I'm not able to write it very well. Okay, so what it means is that y plus 85 degrees will give us 180 degrees. So y is equal to 180 degrees minus 85 degrees, and y will give us 95 degrees. So we use the property of cyclic quadrilaterals to find s and y. Let's consider the next example here. So in this example, we can see that we have PQ as a chord. Now, the line QS passes through O, which is the center. As I said in this video, whenever you see O at the middle of the circle and a line passes through it, it means that that line is the diameter, or O is the center. So here, because QS passes through the center, which is O, QS is a diameter. PR is also a diameter. Now look at it very well. We know that a line drawn from the center of the circle to a point on the circumference is the radius. So what it means is that line OP is a radius. Line OQ is also a radius. What do you know about radius of a circle? We know that it's always equal. So what it means is that line OP is equal to line OQ. So this is what I mean. Line OP here is equal to line OQ. Now whenever you see this, what comes to your mind? Isosceles triangles. We know that for isosceles triangles, two sides of the triangle are equal. So OP is equal to OQ. And because two sides are equal, the angles created at the basis of those two sides will also be equal. So if the angle created here is S, it means that the angle created here is also going to be S. So that is what this point is telling us. Triangle POQ is an isosceles triangle. So QPO, that is the angle created here, will also be S because the angle here is S. So what it means is that because POQ is an isosceles triangle, if the angle formed here is S, the angle created here will also be S. So we have here to be S, here to be S, and we have this exterior angle here for the triangle to be 75 degrees. Now looking at this very carefully, how do we find S? If you remember the properties about triangles, we said that an exterior angle of a triangle is equal to the sum of its interior opposite angles. This here, this 75 degrees that you have here, is an exterior angle of this triangle here. Now, because 75 degrees is an exterior angle, we are saying that if you say the interior opposite angles of 75 degrees are S and S. Hope that is clear. So let's study it very well. Let's assume that we have taken the circle away. you can see that 75 degrees here is the exterior angle. The angle that will be formed here is its interior angle. So S and S here are the interior opposite angles of this exterior angle here. We explain this into details in the videos about triangles. Now we know that an exterior angle of a triangle is equal to the sum of its interior opposite angle. So what this means is that S plus S is equal to 75 degrees. This will give us 2S is equal to 75 degrees and S is equal to 37.5 degrees. Once again, this is one way of solving the question. Somebody can also choose another way to solve the question. All that matters is that you study the diagram very carefully, then you pick the properties that will help you to solve the question. So try finding the value of S using another property and see if you're able to arrive at the answer, which is S is equal to 37.5 degrees. Usually, one method will give you the answer faster than the another method. Because you are dealing with time in an examination, you usually want the method that is faster. That is why in this video, I use the method that are faster. But if you are not conversant with it, you can also try other methods and see using the properties that you've learned, and you see that you arrive at the same answer. Thank you for watching this video. See you in the next video where we will take more questions on finding the value of angles in a circle. Bye bye.
Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it.
We are on the topic plane geometry, and this is going to be the last video on plane geometry. In the previous video, we solved some questions on finding the value of angles in a circle. In this video, we are going to solve 2 more questions. So let's pick the first one. The first one says that in the diagram below, POR is the diameter of the circle. Angle QPR is equal to A degrees. Angle PRS is equal to 4A plus 12 degrees. Find the value of A. Okay, so this is the question that we have been given, and we are supposed to find the value of A. So let's analyze the question. The question told us that POR is the diameter. So you know that line PR passing through O is the diameter. Now, because it's the diameter, what property do you know about angles that diameters create at the circumference? You know that that angle there will be 90 degrees. So because it's POR is the diameter, we know that the angle that will be created by PR, that is from P to this side, from R to this side, which is Q. So from P to Q, from R to Q, the angle that will be created here at Q by the line PR, the angle there will be 90 degrees. The question told us that this angle QPR is A. Then this exterior angle here of the triangle is 4A plus 12 degrees. So you are supposed to find the value of A. Now we know that the angles that the diameter of a circle subtends or creates at the circumference is 90 degrees. Sorry, this was a general mistake. Okay, so it's 90 degrees, not in 90 degrees. It's 90 degrees. Okay, so the angle that the diameter of a circle subtends or creates at the circumference is 90 degrees. So we can say that angle PQR, that is the angle created here, is 90 degrees. So the angle formed here is 90 degrees. Now, how can you use this information here to find A? Look at this very well. Consider the triangle PQR. Let's consider that triangle very, very well. We know that we have this interior angle here to be A, this interior angle here to be 90 degrees. Now, this is an exterior angle. The interior opposite angles of this exterior angle here is A and 90 degrees. So the interior opposite angle of the exterior angle here is A and 90 degrees. What property do we have about interior opposite angles and exterior angles? We know that the sum of the exterior angle of a triangle is equal to, the exterior angle of a triangle is equal to the sum of its interior opposite angle. So this exterior angle here, which is 4A plus 12 degrees, its interior opposite angles are A and 90 degrees. So what this means is that 4A plus 12 degrees is equal to the sum of its interior opposite angles, which are A and 90 degrees. So 4A plus 12 degrees is equal to A plus 90 degrees. In the video on the properties of triangles, we explain this interior opposite angles and this exterior angle property. We explain that into details. So if you are a bit confused, go and watch that video and it will make things clear. So we know that 4A plus 12 degrees is equal to A plus 90 degrees. So we group like terms. We are going to have 4A minus A is equal to 90 degrees minus 12. 3A will give us 78 degrees. We divide both sides by 3 and A is giving us 26 degrees. So using these properties, we have been able to find A. Let's move on to the last question. In the diagram below, tangent PE and tangent PB to a circle with the center O are drawn from a point P outside the circle. The radius of the circle is 5 centimeters and the length of line OP is 13 centimeters. Find the length of line PA and the length of line PB. So the preamble explains everything in the diagram. The preamble explains everything in the diagram. We have a tangent PA and PB, and you are saying that PA and PB are tangent to the circle from a point outside the circle, which is point B. If the radius of the question has been given to us and OP has also been given to us, so we are supposed to find PA and PB. So let's begin with PA, then from there we move on to PB. What this means is that because the radius of the circle is 5 centimeters, it means that from O to A is 5 centimeters, from O to P is 13 centimeters. Now, what do we know about this? What property of a circle can help us to find PA? We know that a tangent to a circle makes an angle of 90 degrees to the radius or diameter at the point of contact. So if you draw a tangent to the circle, that is from point P to point A, it makes an angle of 90 degrees to the radius at the point of contact. So at the place where the radius will meet the tangent, the angle created there is 90 degrees. So following this property, we can say that angle OAP, that is the angle created here, is 90 degrees. I hope that is clear. So with this property, we have been able to deduce that this angle here is 90 degrees. Now how can this help us? Because we have this angle here to be 90 degrees, we have a right angled triangle. So we can use the Pythagoras theorem to find the other length that we don't have. If we draw this diagram very well, we are just considering the triangle PAO. So it means that this is going to be the length PA. The length PA that we have here, this is going to be it. Now 13 centimeters is going to be the hypotenuse, since that is the longest side or the side facing the right angle. Then OA is going to be the base of the triangle. So that is the radius, that is 5 centimeters. I hope that is clear. So we just got this diagram here from what we have here. 13 centimeters is the side facing the right angle. It means that that is the hypotenuse. So it means that PO or OP is the hypotenuse. OA is the base, that is the side that the 90 degrees or the right angle sits on. So you see it sits on this side, so OA is the base. Then the other side is what we have here, which is AP or PA. So with this, we can use the Pythagoras theorem to find PA or AP. From the Pythagoras theorem, we know that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So it means that OP squared is equal to OA squared plus PA squared. We learned this in the video on mensuration, where we use the Pythagoras theorem a lot. So you can go and watch that video and you understand what we mean by the Pythagoras theorem. So basically what it says is that the square of the longer side, which is OP squared, is equal to the sum of the squares of the other two sides. So OA squared plus PA squared. Now we know that OP, that is the length of OP, is 13 centimeters, so 13 squared. We also know that OA is 5 centimeters, so 5 squared. Then we have plus PA squared. So we are grouping like terms. We are going to have 13 squared minus 5 squared is equal to PA squared. 13 squared minus 5 squared will give us 144. If you do this on your calculator, you get 144. We have PA squared. To make PA the subject, what we do is that we take square root of both sides. So we take square root of 144. We take square root of PA squared. So if you take positive square roots of both sides, PA will give us 12 centimeters. So we have been able to find PA. Now let's move on. We have now been able to find PA. The question said we should find both PA and PB. What property will help us to find PB? We know that the length of two tangents from a point outside the circle are equal. So if you have a common point here, if you draw a tangent to the circle to this side and draw a tangent to the circle to this side, from the videos on the properties of circle, the property 10 told us that when this happens, the length of the two tangents are equal. So what this means is that PB is equal to PA. So if PA is 12 centimeters, then PB is also 12 centimeters. Thank you for watching this video and all the videos on plane geometry.